Section 14 of National Geographic Magazine, Volume 3. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Maria Lupe Leblanc, Raleigh, North Carolina. An Expedition to Mount St. Elias, Alaska, by Israel C. Russell. Part 3. Sketch of the geology of the St. Elias region. General features. In the preceding narrative, many references have been made to the character of the rocks and to the geological structure of the region explored. It was not practicable during the journey to carry on detailed geological studies, but such facts as were noted are of interest for this reason, if for no other. They relate to a country previously unknown. My reconnaissance enabled me to determine that there are 3 well-defined formations in the St. Elias region. These are 1. The sandstones and shales about Yakutat Bay and westward along the foot of the mountain to Icy Bay, named the Yakutat System. 2. A system of probably later date composed of shale conglomerate, limestone, sandstone, etc., best exposed in the cliffs of Pinnacle Pass and along the northern and western borders of the Samovar Hills, and named the Pinnacle System. 3. The metamorphic rocks of the main St. Elias Range, called the St. Elias Schist. Yakutat System. The rocks of this system are of gray and brown sandstones and nearly black shales. They are uniform in lithological character over a large area, and are usually greatly crushed and seamed. So great has been the crushing to which they have been subjected that it is difficult to work out a hand specimen with fresh surfaces. Fragments broken out with a hammer are almost invariably bounded by planes of previous crushing, and are usually somewhat weathered. These rocks form the bold shores of Yakutat and Disenchantment Bays, and were the only rocks seen along our route from Yakutat Bay to Pinnacle Pass. The whole of the Hitchcock Range is composed of rocks of this series, as are also the Che Hills, and the hills west of Icy Bay, and the southern portion of the Samovar Hills. North of Pinnacle Pass there are rocks undistinguishable lithologically from those about Yakutat Bay. These are exposed in Mount Owen and on each side of Dome Pass. They also form the bold spurs about the immediate bases of Mount Augusta, Mount Malaspina, and Mount St. Elias. In the 3 instances last named, these rocks dip beneath the schist forming the crest of the St. Elias Range, and it is probable that a great overthrust there took place before the formation of the faults, to which the present relief of the mountains is due. All the mountain spurs of Mount Cook, so far as is known, are composed of sandstones and shales of the Yakutat series, with the exception of the Pinnacle Pass cliffs. Nearly all the debris on the glaciers, from Disenchantment Bay to the Seward Glacier, and probably beyond, is derived from the rocks of this system. The distribution of the rocks from which the debris was derived may be ascertained in a general way, by tracing out the sources of the glaciers. Medial moraines in the Hayden and Marvine glaciers, however, have their sources in the northern slope of Mount Cook, and are composed of gabbro and serpentine. These rocks were not seen in place, and their relation to the Yakutat series can only be conjectured. Although the rocks of this system are stratified, it is impossible to determine their thickness, for the reason that they have been greatly crushed and overthrust. This is well illustrated in the Hitchcock Range, which, as already explained, trends about northeast and southwest, and is composed of strata of shale and sandstone, having a nearly east and west strike and a uniform dip toward the northeast. Were the rocks in normal position, their thickness would be incredible. In addition to this negative evidence, there is the crushed condition of the strata to show that movement has taken place all through their mass, and in a few instances thrust faults were distinguished dipping northeastward at about the same angle as the lines of bedding. In the crushing to which the rocks have been subjected, the shales have suffered more than the sandstones, and have been drawn out into wedge-shaped masses, the sharp edges of which usually point toward the northeast, which is presumably the direction from which the crushing force acted. The hypothesis that the rocks in the St. Elias region have been crushed and overthrust explains many otherwise inharmonious facts, and accounts for the superposition of the St. Elias schist upon rocks of the Yakutat system. Coal has been discovered in the rocks of the Yakutat system about 2 miles west of the southern end of Disenchantment Bay, and is reported to be of workable thickness. I saw thin lignite seams at the surface of this locality, but as the shafts were filled with water, I was unable to examine the coal in the openings and cannot vouch for its thickness. Samples obtained from the mine show it to be a black lignite, which would apparently be of value for fuel. Fossil leaves are reported to occur in connection with the lignite, but these have never been seen by anyone who could identify them. The rocks of the Yakutat system, wherever seen, dip northeastward except when greatly disturbed near fault lines. East of Disenchantment Bay, the inclination of the beds is from 15 degrees to 20 degrees. Farther westward, the dip increases gradually all the way to the Hitchcock Range, where the prevailing inclination is from 30 degrees to 40 degrees, and frequently still greater. Beneath Mount Malaspina and Mount St. Elias, the Yakutat sandstones dip northeastward at an angle of about 15 degrees, and in the hills west of Icy Bay, the dip is about the same. Exceptions to the prevailing dips occur along the immediate shore of Yakutat Bay, northwest of Knight Island, and at the southern extremity of each of the mountain spurs between Yakutat Bay and Blossom Island. At these locations, the rocks are frequently vertical or nearly so, owing their high dip to the proximity of lines of displacement. The faults indicated by these unusual dips also mark the boundary between the mountains and the seaward stretching plateau of alluvium and ice. The crushing, overthrusting, and faulting that has affected the rocks of this system render it doubtful whether the coal seams which occur in it, even if of requisite thickness, can be worked to advantage. Some of the samples of coal obtained at the openings made near Yakutat Bay were slicken-sided, showing that movements in the coal seam had there taken place. As already stated, the rocks of the Yakutat series are remarkably uniform in character throughout the extent now known, and offer but little variety. The sandstones are intersected in every direction by thin quartz seams, which stand in relief on the weathered surfaces, giving the rocks a peculiar and characteristic appearance. The first important change in the geology along the route traversed by us was met on reaching Pinnacle Pass. Pinnacle System. The rocks of this system, as already stated, are best exposed in the great fault scarp forming the northern wall of Pinnacle Pass. They are more varied in composition and have preserved a better record of the conditions under which they were deposited than the sandstones and shales of the Yakutat system. Only an approximate section of the rocks exposed in the Pinnacle Pass cliff was obtained. Sandstone and conglomerate weathering into spires, 500 feet. Evenly bedded, sandy shale in thin layers, 600 feet. Coarse conglomerate, boulders of crystalline rock, 50 feet. Thinly bedded, dark-colored sandstone and shale, 500 feet. Reddish conglomerate, 10 feet. Light gray sandstone with thin, irregular coal seams, 40 feet. Total, 1,800 feet. There is also a compact crystalline gray limestone near the upper portion of the series, which escaped notice in the cliffs. At the end of the Pinnacle Pass cliffs, however, where the rocks are turned northward by the great fault which decides the course of the Seward Glacier, and dip eastward at a high angle, the limestone is well exposed and has a thickness of about 50 feet. In many places, the surface of the layers are covered with fragments of large pecten shells. Associated with the limestone, there are reddish shales, much crushed and broken, and a peculiar conglomerate. The pebbles in the conglomerate are of many varieties and were observed at places along the Pinnacle Pass cliffs. Their most marked peculiarity lies in the fact that they have been sheared by a movement in the rocks and sometimes broken into several fragments, which have been reunited, probably by pressure. These faulted pebbles are characteristic of the strata from which they were derived. Similar pebbles were afterward obtained in the Marvine Glacier near its junction with the Malaspina Glacier, thus indicating that there are other outcrops of the conglomerate about Mount Cook, near where the Marvine Glacier has its source. 2 quartz pebbles from the conglomerate of the Pinnacle Pass are shown in the accompanying illustrations. The larger pebble, shown in Figure 7, is of bluish-gray quartz, and the smaller one, depicted in Figure 8, is of white quartz. The fragments into which they have been broken are now firmly united. The engravings are photomechanical, Moss process, reproductions from the objects. In the northern and western part of the Samovar Hills, the rocks of the Pinnacle system again appear, forming a bold angular ridge, curving southward and reaching the border of the Agassiz Glacier. The southern face of this range is precipitous, and, like the Pinnacle Pass cliffs, exhibits the edges of northward dipping strata. Its northern and western slopes are heavily snowbound. It is in reality a continuation of the Pinnacle Pass fault, but thrown out of line by the cross fault which marked out the course of the Seward Glacier. Figure 7. Faulted pebble from Pinnacle Pass. The Yakutat and Pinnacle systems are so easily recognized that the distribution can be distinguished at a glance, when the outcrops are not concealed beneath the nearly universal covering of snow. The rocks of the Yakutat series are heavily bedded sandstones and shales, and have in general a light brown tint, while the rocks of the Pinnacle series are thinly bedded and dark in color, appearing black at a distance. The presence of pectin, Patinopectin corinus, Gould, in the limestone of the Pinnacle series has already been mentioned. Other fossils were obtained from sandstones and shales at the crest of the cliffs above Pinnacle Pass at an elevation of 5,000 feet. These were submitted to Dr. W. H. Dahl, who kindly identified them as follows: Maya arenaria Linnaeus, Mytilus edulus Linnaeus, Leda fossa Baird or Linnaeus Vianuta Faber, Macoma inconspicua Broderick and Sowerby, Cardium Islandicum Linnaeus, Litorina atcana Dahl. All of these species are stated by Dahl to be still living in the oceanic waters of Alaska. The very recent age of the rocks in which they occur is thus established. Figure 8. Faulted pebble from Pinnacle Pass. In strata closely connected with the layers in which these shells were found, there occur many fine leaf impressions, a few of which were brought away. These have been examined by Professor L. F. Ward, who has identified them with 4 species of salix, closely resembling living species. The report on these interesting fossils forms Appendix D. The age indicated by both invertebrates and plants is late Tertiary, Pliocene, or early Pleistocene. This determination is of great significance when taken in connection with the structure of the region and shows that the mountains in the St. Elias region are young. Not only was a part, at least, of the Pinnacle system deposited during the life of living species of mollusks, but also the whole of the Yakutat series, the stratigraphic position of which is, if my determination is correct, above the Pinnacle system. After the sediments composing the rocks of these 2 series were deposited in the sea as strata of sand, mud, etc., they were consolidated, overthrust, faulted, and upheaved into one of the grandest mountain ridges on the continent. Then, after the mountains had reached a considerable height, if not their full growth, the snows of winter fell upon them, and glaciers were born. The glaciers increased to a maximum, and their surfaces reached from 1,000 to 2,000 feet higher than now on the more southern mountain spurs, and afterward slowly wasted away to their present dimensions. All of this interesting and varied history has been enacted during the life of existing species of plants and animals. The relative age of the Yakutat and Pinnacle series is the weakest point in the history sketched above. The facts on which it rests are as follows. At Pinnacle Pass, the sandstones and shales forming the southern wall belong to the Yakutat system and are much disturbed, while the northern wall, or the heaved side of the fault, is composed of the rocks of the Pinnacle system inclined northward at an angle of 30 degrees or 40 degrees. North of this fault scarp, in the foothills of Mount Owen, sandstones and shales, seemingly identical with those of the Yakutat system, again occur, although their direct connection with the rocks south of Pinnacle Pass was not observed owing to the snow that obscured the outcrops. Again, at Dome Pass, a similar relation seems evident, but cannot be directly established. The immediate foothills of Mounts Augusta, Malaspina, and St. Elias are also of sandstone, lithologically the same as the Yakutat series. The conclusion that the Yakutat system is younger than the Pinnacle Pass rocks was reached in the field after many other hypotheses had been tried and found wanting, and to my mind it explains all the observations made. Even should the supposed relations of the two series under discussion be reversed, it would still be true that a very large part of the rocks of the St. Elias region were deposited since the appearance of living species of mollusks and plants, and that the prevailing structure of the region was imposed at a still later date. This will appear more clearly after examining the structure of the region. St. Elias schist. The rock forming several thousand feet of the upper portion of the St. Elias range is a schist in which the planes of bedding are preserved. The dip of the strata is northeastward and has exerted a decided influence on the weathering of the mountain crests. As the opportunities for examining this formation were unsatisfactory, a detailed account of it will not now be attempted. Geological structure. The abnormal thickness of the Yakutat series, due to crushing and overthrust, has been referred to, as has also the superposition of the St. Elias schist upon rock supposed to belong to the Yakutat system. The plane of contact between the sandstone and the overlying schist of the St. Elias range dips northeastward at an angle of about 15 degrees, corresponding as nearly as can be determined with the dip of the strata in the sandstone itself. All of the observations made in this connection indicate that the schist has been overthrust upon the sandstones. After this took place, the great faults to which the range owes its present relief were formed. About Mount Cook, however, and in the elevated plateau east of Yakutat Bay, the conditions are different from those observed along the base of the St. Elias range. The only displacements known in the Yakutat system south and east of Pinnacle Pass is the Great Fault, which presumably exists where the rocks of the foothills disappear beneath the gravel and glaciers of the Piedmont region. The faults referred to belonging to the same series as those which determine the southern and southwestern borders of the St. Elias range and many of the foothills south of the main escarpment. Besides the great faults which trend from St. Elias toward the northeast and northwest, there are several cross faults, one of which determines the position of the Seward Glacier through a portion of its course, while another marks out the path of the Agassiz Glacier, and two others may be recognized just east of the summit of St. Elias, which have dropped portions of the eastern end of the orographic block forming the crowning peak of the range. The southern face of Mount St. Elias is a fault scarp. The mountain itself is formed by the upturned edge of a faulted block in which the stratification is inclined northeastward. As has just been mentioned, the mountain stands at the intersection of two lines of displacement, one trending in a northeasterly and the other in a northwesterly direction. The one trending northwestward extends beyond the end of the northeast fault. The point of union is at the pass between Mount St. Elias and Mount Newton. The upturned block, bounded on the southwest by a great fault, projects beyond the junction with the northeasterly fault. It is this projecting end of a roof-like block that forms Mount St. Elias. That this is the case may be clearly seen when viewing the mountain from the glacier near the base of Mount Owen. Such a view is shown on Plate 20. The crest line of St. Elias extends with a decreasing grade northwestward from the culminating peak, and the northern slope of the ridge is the surface of the tilted block. From what has been stated already, it will be seen that the St. Elias range is young. Its upheaval, as indicated by our present knowledge, was since the close of the Tertiary. The breaking of the rocks and their upheaval is an event of such recent date that erosion has scarcely modified the forms which the mountains had at their birth. The formation of glaciers followed the elevation of the region so quickly that there was no opportunity for streams to act. The ice drainage is consequent upon the geological structure and has made but slight changes in the topography due to that structure. About Mount Cook and in the elevated plateau east of Yakutat Bay, there has been deeper erosion than about Mount St. Elias. The glaciers in this region occupy deep valleys radiating from the higher peaks, but whether these are really valleys of erosion is not definitely known. In some instances, changes of dip on opposite sides of the valleys indicate that they may in part be due to faulting. But owing principally to the fact that every basin has its glacier. It has not been practicable, up to the present time, to determine how they were formed. The crests of the mountains are always sharp and angular by reason of the rapid weathering of their exposed summits. But while disintegration is rapid, no evidences of pronounced decay are noticeable. The peaks on the summits of the St. Elias Range are either pyramids or roof-like crests with triangular gables. These forms have resulted from the weathering of schist in which the plains of bedding are crossed by lines of jointing. End of section 14. Recording by Maria Lupe Leblanc, Raleigh, North Carolina.
Section 15 of National Geographic Magazine, Volume 3. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by MaryAnn Spiegel. Glaciers of the St. Elias region. Natural divisions of glaciers. The glaciers of the St. Elias region form two groups. The ice streams from the mountain are of the type found in Switzerland, and hence termed alpine glaciers. The great plateau of ice along the ocean formed by the union and expansion of alpine glaciers from the mountains belongs to a class not previously described, but which in this paper have been called Piedmont glaciers. The representative of the latter type between Yakutat Bay and Icy Bay is the Malaspina Glacier. Both types are to be distinguished from continental glaciers. Alpine glaciers. The glaciers in the mountains are all of one type, but present great diversity in their secondary features, and might be separated into 3 or 4 subordinate divisions. The great trunk glaciers have many tributaries, and drain the snows from the mountains through broad channels, which are of low grade throughout all the lower portions of their courses. Besides the trunk glaciers and the secondary glaciers which flow into them, there are many smaller glaciers which do not join the main streams, but terminate in the gorges or on the exposed mountain-sides in which they originate. These have nearly all the features of the larger streams, but are not of sufficient volume to become rivers of ice. A minor division of the alpine glaciers for which it is convenient to have a special name includes those that end in the sea and, breaking off, form icebergs. These may be designated as tidewater glaciers. Typical examples of this class are furnished by the Dalton and Hubbard glaciers, but other ice streams having the same characteristics occur in Glacier Bay, in Taku Inlet, and at the heads of several of the deep fjords along the coast of southeastern Alaska. A noticeable feature of the alpine glaciers of Alaska is that they expand on passing beyond the valleys through which they flow, and form delta-like accumulations of ice on the plains below. This expansion takes place irrespective of the direction in which the glaciers flow, and, so far as may be judged from the many examples examined, is independent of the debris that covers them. It should be remembered, however, that none of the Alaskan glaciers thus far studied show marked inequalities in the distribution of the moraines upon their surfaces. Should one side of a glacier, on leaving a canyon, be heavily loaded with marginal moraines, while the opposite border was unprotected, it is to be presumed that a deflection of the ice would take place, similar to the change in direction recorded by the moraines around Mono Lake, California. The normal tendency of ice, when not confined, to expand in all directions and form a plateau is illustrated on a grand scale by the Malaspina Glacier. The most important ice streams about Mount St. Elias and Mount Cook are indicated on the map forming Plate 8. The Tyndall, Guyot, and Libby glaciers and the lower part of the Agassiz Glacier there represented are taken from a map published by H. W. Topham. All of the other glaciers indicated on the map were hastily surveyed during the present expedition and are described to some extent in the accompanying narrative. By far the most important of these is the one named Seward Glacier. The Seward Glacier is of the alpine type and is the largest tributary of the Malaspina Glacier. Its length is approximately 40 miles, and its width in the narrowest part, opposite Camp 14, is about 3 miles. The main amphitheater from which its drainage is derived is north of Mount Owen and between Mount Irving and Mount Logan. The general surface of the broad level floor of this névé field has an elevation of approximately 5,000 feet. The snow from the northern and western side of Mount Irving, from the northern slope of Mount Owen, and from numerous valleys and canyons in the vast semicircle of towering peaks joining these two mountains, unite to form the Great Glacier. There is another amphitheater between Mount Owen and the Pinnacle Pass cliffs, supplied principally by snows from the northwestern slope of Mount Cook, which sends a vast flood of ice and snow into the main drainage channel. Other tributary glaciers descend the steep slopes of Mount Augusta and Mount Malaspina, and a lesser tributary flows eastward from Dome Pass. All of these ice drainage lines converge toward the narrow outlet of Camp 14, Plate 8, and discharge southward down a moderately steep descent several miles in length. Below Camp 14 there are other névé fields bordering the glacier, which contribute no insignificant amount of ice and snow to its mass. Between the extremity of the Hitchcock Range and the Samovar Hills, the path of the glacier is again contracted and greatly broken as it descends to the plateau below. The Seward Glacier, like all ice rivers of its class, has its névé region above and its ice region below. The limit between the two is the lower margin of the summer snow, and occurs just above the ice fall between the southern extremity of the Hitchcock Range and the Samovar Hills. All the névé region is pure white and without moraines, except at the immediate bases of the most precipitous cliffs. At the bases of the Corwin Cliffs, which rise fully 2,000 feet above its border, no debris can be distinguished even in midsummer. An absence of moraines along the base of Pinnacle Pass cliffs was also noticed during our first visit, but when we returned over the same route in September, the melting of the snow had revealed many large patches of dirt and disintegrated rock. In several places near the bases of steep cliffs, strata of dirty ice, containing many stones, were observed in deep crevices. It was evident that vast quantities of debris were sealed up in the ice along the borders of the glacier, only to appear at the surface far down the stream where summer melting exceeds the winter accumulation. The surface of the glacier below the lower fall is composed of solid ice with blue and white bands, and has broad moraines along its borders. The course of the glacier, after entering the great plateau of ice to which it is tributary, may be traced for many miles by bands of debris along its side. These moraines belong to the Malaspina Glacier and have already been referred to. At the outlet of the upper amphitheater, about 6 miles above Mount Owen, there is an ice fall which extends completely across the glacier. Below the pinnacles and crevasses formed by this fall, the ice is re-cemented and flows on with a broad, gently descending surface, gashed, however, by thousands of crevices as shown in Plate 20, to the end of the Pinnacle Pass cliffs. It there finds a more rapid descent, and becomes crevassed in an interesting way. The slope is not sufficient to be termed a fall, but it causes a rapid in the ice stream. The change of grade in the bed of the glacier is first felt about a mile above Camp 14. A series of crevasses there begins which extends 4 or 5 miles downstream. At first the cracks are narrow and tend upstream in the manner usual with marginal crevasses. Soon the cracks from the opposite sides meet in the center and form a single crevasse, bending upstream in the middle. A little lower down, the crevasse becomes straight, showing that the ice in the center of the current flows more rapidly than at the sides. The more rapid movement of the center is indicated by the form of the crevasses all the way down the rapid. After becoming straight, they bow in the center and form semilunar gashes, widest in the center and curving upstream at each extremity. Still farther down they become more and more bent in the center and at the same time greatly increased in breadth. Still lower the curve becomes an angle and the crevasses are V-shaped, the arrow-like point directed downstream. These parallel V-shaped gashes set in order, one in front of the other, are what gives the glacier the appearance of watered ribbon when seen from a distance. With the change in direction and curvature of the crevasses, there is an accompanying change in color. The cracks in the upper part of the rapid are in a white surface and run down into ice that looks dark and blue by contrast. Lower down, as the cracks increase in width, broad white tables are left between them. Cross fractures are formed, and the sides of the table begin to crumble in and fill up the gaps between. As the surface melts, the tables lose their pure whiteness and become dust-covered and yellow. But the blocks falling into the crevasses expose fresh surfaces and fill the gulfs with pure white ice. In this way the color of the sides of the crevasses changes from deep blue to white, while the general surface loses its purity and becomes dust-covered. Far down the rapid, where the V-shaped crevasses are most pointed, the tables have crumbled away and filled up the gulfs between, so that the watered ribbon pattern is distinguished by color alone. The scars of the crevasses formed above are shown by white bands on a dark dust-colored surface. Before the lower fall is reached, nearly all traces of the thousands of fissures formed in the rapids above had disappeared. On looking down on the rapids from any commanding point, the definite arrangement of the crevasses along the center of the ice stream at once attracts attention, and their order suggests a rapid central current in the stream. Below Camp 14, for at least 2 or 3 miles, as well as at many places above that point, the Seward Glacier flows between banks of snow. Along its border there are marginal crevasses trending upstream, and in the adjacent banks there are similar breaks trending downstream. When the two systems meet, there is a line of irregular crevasses, exceedingly difficult to cross, which mark the actual border of the flowing ice. A similar arrangement of marginal crevasses and of shore crevasses has been referred to in connection with the Marvine Glacier, and was observed in many other instances. While occupying Camp 14, we could hear the murmur of waters far down in the glacier below our tent, but there were no surface streams visible. Crashing and rumbling noises made by the slowly moving ice frequently attracted our attention, and sometimes at night we would be awakened by a dull thud, accompanied by a trembling of the rocks beneath us, as if a slight earthquake had occurred. Occasionally a pinnacle of ice would fall and be engulfed in the crevasses at its base. These evidences of change indicated that the movements of the Seward Glacier were constantly in progress. A short base line was measured and sites taken to well-marked points in the Seward Glacier for the purpose of measuring its motion. The angles between the base line and lines of sight to the chosen points were read on several successive days, but when these observations were compared they gave discrepant results. The measurements which seem most reliable indicate that the central part of the ice stream has a movement of about 20 feet a day. This is to be taken only as an approximation, which needs to be verified before much weight can be attached to it. Characteristics of alpine glaciers above the snow line. The surface of the névé is white, except near its lower limit in late summer, where it frequently becomes covered with dust blown from neighboring cliffs. It is almost entirely free from moraines, but at the bases of steep slopes, small areas of debris sometimes appear at the surface when the yearly melting has reached its maximum. The absence of moraines is accompanied by an absence of glacial tables, sand cones, and other details of glacial surfaces due to differential melting. Streams seldom appear at the surface, for the reason that usually the water produced by surface melting is quickly absorbed by the porous strata beneath. Yet the crevasses are frequently filled with water, and sometimes shallow lakes of deep blue occur at the bottoms of the amphitheaters and form a marked contrast to the even white of the general surface. Crevasses are present or absent according to the slope of the surface on which the névé rests. In the crevasses the edges of horizontal layers of granular ice are exhibited, showing that the névé down to a depth of at least 100 or 200 feet is horizontally stratified. In the St. Elias region, the strata are most frequently from 10 to 15 feet thick, but in a few instances, layers without partings over 50 feet thick were seen. The surface is always of white, granular ice, but in the crevasses, the layers near the bottom appear more compact and bluer in color than those near the surface. Some of the most striking features of the névé are due to the crevasses that break their surfaces. The orderly arrangement of marginal crevasses and of the interior crevasses at the rapids in the Seward Glacier have already been referred to. But there are still other crevasses, especially in the broad, gentle sloping portions of the snow fields where the motion is slight, which, although less regular in their arrangement, are fully as interesting. The crevasses on such slopes generally run at right angles to the direction in which the snow is moving. On looking down on such a surface, the breaks look like long, clear-cut gashes which have stretched open in the center, but taper to a sharp point at each end. The ability of the névé ice to stretch to a limited extent is thus clearly shown. The initiation of the crevasses seems to be due to the movement of the névé ice over a surface in which there are inequalities of such magnitude that the ice cannot stretch sufficiently to allow it to accommodate itself to them, so that strains are produced which result in fractures at right angles to the line of general movement. Crevasses found where the grade is gentle vary from a fraction of an inch to 10 or 15 feet in width, and are sometimes 2,000 or 3,000 feet long. Broader gulfs are seldom formed unless the slope has an inclination of 15 degrees or 20 degrees. The grandest crevasses are in the higher portions of the névé, and occur especially on the borders of the great amphitheaters. In such situations the crevasses are usually fewer in number, but are of greater size than in equal area lower down. A length of 3,000 or 4,000 feet and a breadth of 50 or more is not uncommon. The finest and most characteristic glacial scenery is found among these great canyon-like breaks. Standing on the border of one of these gulfs, as near the brink as one cares to venture, their full depth cannot usually be seen. In some instances they are partially filled with water of the deepest blue, in which the ice walls are reflected with such wonderful distinctness that it is impossible to tell where the ice ends and its counterfeit begins. The walls of the crevasses are most frequently sheer cliffs of stratified ice, with occasional ornamentations formed of ice crystals or a pendant icicle. After a storm they are frequently decorated in the most beautiful manner with fretwork and cornice of snow. The bridges spanning the crevasses are usually diagonal slivers of ice left where the clefts overlap, but at times, especially in the case of the larger crevasses, there are true arches resembling the natural bridge of Virginia, but on a larger scale, spanning the blue canyons and adding greatly to their strange, fairy-like beauty. The most striking feature of these cracks is their wonderful color. All tints, from the pure white of their crystal lips down to the deepest blue of their innermost recesses, are revealed in each gash and rent in the hardened snow. Above the snow line, all of the mountain tops that are not precipitous are heavily loaded with snow. Where the snow breaks off at the verge of a precipice and descends in avalanches, a depth of more than 100 feet is frequently revealed, but in the valleys and amphitheaters the snow has far greater thickness. Pinnacles and crests of rock, rising through the icy covering, indicate that the thickness of the névé must be many hundreds of feet. There are no evidences of former glaciation on the mountain crests which project above the névé fields. There are no polished and striated rock surfaces, or glaciated domes to indicate that the mountains were ever covered by a general capping of ice, as has been postulated for similar mountains elsewhere. When the glaciers had their greatest expansion, the higher mountains were in about their present condition. The increase in the volume of the glaciers was felt almost entirely in their lower courses. Characteristics of alpine glaciers below the snow line. The first feature that attracts attention on descending from the névé region to the more icy portions of the glaciers is the rapid melting everywhere taking place. Every day during the summer the murmur and roar of rills, brooks, and rivers are to be heard in all of the ice fields. The surface streams are usually short, on account of the crevasses which intercept them. They plunge into these gulfs, which are many times widened out by the flowing waters so as to form wells, or moulins, and join the general drainage beneath. The streams then flow either through caverns in the glaciers or in tunnels at the bottoms. While traversing the glacier one may frequently hear the subdued roar of rivers coursing along in the dark chambers beneath when no other indication of their existence appears on the surface. When these subglacial streams emerge, usually near the margin of the ice, they issue from archways forming the ends of tunnels, and perhaps flow for a mile or two in the sunlight before plunging into another tunnel to continue their way as before. The best example of a glacial river seen during our exploration was near the western border of the Lucia Glacier. It is shown in the illustration forming Plate 12, which is reproduced mechanically from a photograph. This Styx of the ice world has been described on an earlier page. The lakes formed at the southern end of nearly every mountain spur projecting into the Malaspina Glacier discharge through tunnels in the ice, which are similar in every way to those formed by the stream already mentioned. In the beds of the glacial streams there are deposits of sand and gravel, and when the streams expand into lakes, these deposits are spread over their bottoms in more or less regular sheets. When streams from the mountains empty into the lakes, deltas are formed. While these deltas have the same characteristics as those built in more stable water bodies, many changes in detail occur owing to the fluctuation of the water level. One of the tunnels leading to a dry lake bed at the end of the Hitchcock Range was explored for several rods and found to be a high arching cavern following a tortuous course, and large enough to allow one to drive a coach and four through it without danger of collision. Its floor was formed of gravel and boulders, and its arching roof was clear ice. Here and there the courses of crevasses could be traced by the stones and finer debris that had fallen in from above, giving the appearance of veins in a mine. The deposit on the floor of the tunnel rested upon ice, and would certainly be greatly disturbed and broken up before reaching a final resting place in case the glacier should melt. In the lake basins, also, the sand and gravel forming their bottoms frequently rested upon substrata of ice, and are greatly disturbed when the ice melts. At the ends of the glaciers, the subglacial and intraglacial drainage issues from tunnels and forms muddy streams. These usually flow out from the foot of a precipice of ice, down which rills are continually trickling. The streams flowing away from the glaciers are usually rapid, owing to the high grade of their built-up channels, and sweeping away large quantities of debris which is deposited along their courses. The streams widen and bifurcate as they flow seaward, and spread vast quantities of boulders, sand, and gravel over the country to the right and left, not infrequently invading the forests and burying the still upright trees. The deposits formed by the streams are of the nature of alluvial fans, over which the waters meander in 1,000 channels. Where this action has taken place long enough, the alluvial fans end in deltas, but should there be a current in the sea, the debris is carried away and formed into beaches and bars along adjacent shores. Should these glaciers disappear, it is evident that these great boulder washes would form peculiar topographic features, unsupported at the apexes, and it might be perplexing to determine from whence came the waters that deposited them. I am not aware that similar washes have been recognized along the southern border of the Laurentide glaciers, but they should certainly be expected to occur there. Another very striking difference in the appearance of the glaciers above and below the snow line is due to the prevalence of debris on the lower portion. The melting that takes place below the snow line removes the ice and leaves the rocks. In this manner the stones previously concealed in the névé are concentrated at the surface and finally form sheets of debris many miles in extent. So far as my observations go, there is nothing to indicate that stones are brought to the surface by any other means than the one here suggested. Upward currents in the ice that would bring stones to the surface have been postulated by certain writers, but nothing sustaining such a hypothesis has been found in Alaska. The moraines on the lower extremities of the alpine glaciers may frequently be separated into individual ridges, which in many instances would furnish instructive studies, but in no case has the history of these accumulations been worked out in detail. With the appearance of moraines at the surface come a great variety of phenomena due to unequal melting. Ridges of ice, sheathed with debris, glacial tables, sand cones, etc., everywhere attract the attention. But these features are very similar on all glaciers where the summer's waste exceeds the winter's increase, and have been many times described. The general distribution of the moraines of the lower portion of the Alpine glaciers of the St. Elias region merits attention. The moraines themselves exhibit features not yet observed in other regions. From Disenchantment Bay westward to the Seward Glacier, the lower portions of the ice streams are covered and concealed by sheets of debris. About their margins the debris fields support luxuriant vegetation, and not infrequently are so densely clothed with flowers that a tint is given to their rugged surfaces. On the extreme outer margins of the moraines there are sometimes thickets and forests so dense as to be almost impenetrable. The best example of forest-covered moraines resting on living glaciers, however, is found along the borders of the Malaspina icefield. Piedmont Glaciers. This type is represented in the region explored by the Malaspina Glacier. This is a plateau of ice having an area of between 500 and 600 square miles, and a surface elevation in the central part of between 1,500 and 1,600 feet. It is fed by the Agassiz, Seward, Marvine, and Hayden glaciers, and is of such volume that it has apparently displaced the sea and holds it back by a wall of debris deposited about its margin. All of its central portion is of clear white ice, and around all its margins, excepting where the Agassiz and Seward glaciers come in, it is bounded by a fringe of debris and by moraines resting on the ice. Along the seaward border, the belt of fringing moraines is about 5 miles broad. The inner margin of the moraine belt is composed of rocks and dirt, without vegetation, and separated more or less completely into belts by strips of clear ice. On going from the clear ice toward the margin of the glacier, one finds shrubs and flowers scattered here and there over the surface. Farther seaward, the vegetation becomes more dense, and the flowers cover the whole surface, giving it the appearance of a luxuriant meadow. Still farther toward the margin, dense clumps of alder, with scattered spruce trees, become conspicuous, while the outer margin spruce trees of larger size form a veritable forest. That this vegetation actually grows on the moraines above a living glacier is proved beyond all question by holes and crevasses which reveal the ice beneath. The curious lakes scattered abundantly over the moraine-covered areas, and occupying hourglass-shaped depressions in the ice, have already been described. From the southern end of the Samovar Hills, where the Seward and Agassiz glaciers unite, there is a compound moraine stretching southward, which divides at its distal extremity and forms great curves and swirl-like figures, indicating currents in the glacier. All the central part of the plateau is, as already stated, of clear white ice, free from moraines. At a distance it has the appearance of a broad snow surface. This is due to the fact that the ice is melted and honeycombed during the warm summer, and the surface becomes vascular and loses its banded structure. A rough, coral-like crust, due to the freezing of the portions melted during the day, frequently covers large areas and resembles a thick hoarfrost. Crevasses are numerous, but seldom more than a few feet deep. They appear to be the lower portions of deep crevasses in the tributary streams, which have partially closed, or else not completely removed by the melting and evaporation of the surface. Many of the crevasses are filled with water, but there are no surface streams and no lakes. Melting is rapid during the warm summer days, but the water finds its way down into the glacier and joins the general subglacial drainage. It is evident that the streams beneath the surface must be of large size, as they furnish the only means of escape for the waters flowing beneath the Agassiz, Seward, and Marvine glaciers, as well as for the waters formed by the melting of the great Malaspina Glacier. The outer borders of the Malaspina Glacier are practically stationary, but there are currents in its central part. Like the expanded ends of some of the Alpine glaciers, as the Galiano and Lucia glaciers, for example, this glacier is of the nature of a delta of ice, analogous in many of its features to river deltas. As a stream in meandering over its delta builds up one portion after another, so the currents in an expanded ice foot may now follow one direction and deposit loads of debris, and then slowly change so as to occupy other positions. This action tends to destroy the individuality of the moraine belts and to form general sheets of debris. The presence of such currents as here suggested has not been proved by measurements, but the great swirls in the Malaspina Glacier and the tongues of clear ice in the upper portions of the debris fields on the smaller glaciers strongly suggest their existence. The Malaspina Glacier is evidently not eroding its bed. Any records that it is making must be by deposition. Should the glacier melt away completely, it is evident that the surface formed of glacial debris and very similar to that now existing in the forested plateau east of Yakutat Bay would be revealed. The former extent of the Malaspina Glacier cannot be determined, but it is probable that during its greatest expansion it extended seaward until deep water was reached, and broke off in bergs in the same manner as do the Greenland glaciers at the present day. Soundings in the adjacent waters might possibly determine approximately the former position of the ice front, and it is possible that submarine moraines might be discovered in this way. The Pimpluna reefs, reported by Russian navigators and indicated on many maps, may possibly be a remnant of the moraine left by the Piedmont Glacier from the adjacent coast. The glaciers west of Icy Bay were seen from the top of Pinnacle Pass cliffs, and are evidently of the same character as the Malaspina Glacier, and fully as extensive. A study of these Piedmont glaciers will certainly throw much light on the interpretations of the glacial records over northeastern North America. Their value in this connection is enhanced by the fact that they are now retreating and making deposits rather than removing previous geological records. The expedition of last summer was a hasty reconnaissance during which but little detail work could be undertaken. The actual study of the ice fields of the St. Elias region remains for those who come later. End of section 15.
Section 16 of National Geographic Magazine, Volume 3. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Jack Daniel, San Francisco, California. Section 16. An Expedition to Mount St. Elias, Alaska, by Israel C. Russell. Part 5. Height and Position of Mount St. Elias. The height and position of Mount St. Elias have been measured several times during the past century with varying results. The measurements made prior to the expedition of 1890 have been summarized and discussed by W. H. Dahl of the United States Coast and Geodetic Survey, and little more can be done at present than give an abstract of his report. The various determinations are shown in the table below. The data from which these results were obtained have not been published, with the exception of the surveys made by the United States Coast Survey in 1874, printed in Report of the Superintendent for 1875. Table: Height and Position of Mount St. Elias. Date 1786. Authority: La Pérouse. Height: 12,672 feet. Latitude: 60 degrees, 15 minutes, 0 seconds. Longitude west: 140 degrees, 10 minutes, 0 seconds. Date 1791. Authority: Malaspina. Height: 17,851 feet. Latitude: 60 degrees, 17 minutes, 35 seconds. Longitude west: 140 degrees, 52 minutes, 17 seconds. Date: 1794. Authority: Vancouver. No height given. Latitude: 60 degrees, 22 minutes, 30 seconds. Longitude west: 140 degrees, 39 minutes, 0 seconds. Date 1847. Authority: Russian Hydrographic Chart 1378. Height: 17,854 feet. Latitude: 60 degrees, 21 minutes, 0 seconds. Longitude west: 141 degrees, 0 minutes, 0 seconds. Date 1847. Authority Tebenkov. Notes. Height 16,938 feet. Latitude 60 degrees, 22 minutes, 36 seconds. Longitude west 140 degrees, 54 minutes, 0 seconds. Date 1849. Authority Tebenkov. Chart 7. Height 16,938 feet. Latitude 60 degrees, 21 minutes, 30 seconds. Longitude west 140 degrees, 54 minutes, 0 seconds. Date 1849. Von Buch, Kanarien Inseln. Height 16,758 feet. Latitude 60 degrees, 17 minutes, 30 seconds. Longitude west 140 degrees, 51 minutes, 0 seconds. Date 1872. Authority English Admiralty Chart 2172. Height 14,970 feet. Latitude 60 degrees, 21 minutes, 0 seconds. Longitude west 141 degrees, 0 minutes, 0 seconds. Date 1874. Authority U.S. Coast Survey. Height 19,500 plus or minus 400 feet. Latitude 60 degrees, 20 minutes, 45 seconds. Longitude west 141 degrees, 0 minutes, 12 seconds. All of the figures given in the table have been copied from Ball's report, with the exception of the position determined by Malaspina. This is from a report of astronomical observations made during Malaspina's voyage, which places the mountain in latitude 60 degrees, 17 minutes, 35 seconds, and longitude 134 degrees, 33 minutes, 10 seconds west of Cadiz. Taking the longitude of Cadiz as 6 degrees, 19 minutes, 7 seconds west of Greenwich, the figures tabulated above are obtained. It was intended that Mr. Kerr's report, forming Appendix B, should contain a detailed record of the triangulation executed last summer, but a careful revision of his work by a committee of the National Geographic Society led to the conclusion that the results were not of sufficient accuracy to set at rest the questions raised by the discrepancies in earlier measurements of the height of Mount St. Elias. And as the work will probably be revised and extended during the summer of 1891, only the map forming Plate 8 will be published at this time. Some preliminary publications of elevations have been made, but these must be taken as approximations merely. Footnote: the shoreline of the map, Plate 8, and the positions of the initial points of baseline of the triangulation are from the work of the United States Coast Survey. The extreme western portion is from maps published by the New York Times and Topham expeditions. All the topographic data are by Mr. Kerr, and all credit for the work and all responsibility for its accuracy rest with him. The nomenclature is principally my own, and has been approved by a committee of the National Geographic Society. End footnote. By consulting the map forming Plate 8, it will be seen that Mounts Cook, Vancouver, Irving, Owen, etc. are not in the St. Elias Range. Neither do they form a distinct range either topographically or geologically. Each of these mountains is an independent uplift, although they may have some structural connection, and are of about the same geological age. Mount Cook and the peaks most intimately associated with it are composed mainly of sandstone and shale belonging to the Yakutat system. Mounts Vancouver and Irving are probably of the same character, but definite proof that this is the case has not been obtained. The St. Elias uplift is distinct and well marked, both geologically and topographically, and deserves to be considered as a mountain range. The limits of this range have not been determined, but, so far as known, its maximum elevation is at Mount St. Elias. The range stretches away from this culminating point both northeastward and northwestward, and has a well-marked V shape. The angle formed by the two branches of the range where they unite at Mount St. Elias is, by estimate, about 140 degrees. Each arm of the V is determined by a fault, or perhaps more accurately, by a series of faults having the same general course, along which the orographic blocks forming the range have been upheaved. The structure of the range is monoclinal and resembles the type of mountain structure characteristic of the Great Basin. The dip of the tilted blocks is northward. The crest of the St. Elias Range, as already stated, is composed of schists which rest on sandstone supposed to belong to the Yakutat system. The geological age of the uplift is, therefore, very recent. The secondary topographic forms on the crest of the range have resulted from the weathering of the upturned edges of orographic blocks in which the bedding planes are crossed by joints. The resulting forms are mainly pyramids and roof-like ridges with triangular gables. Extreme ruggedness and angularity characterize the range throughout. There are no rounded domes or smoothed and polished surfaces to suggest that the higher summits have ever been subjected to general glacial action. Neither is there any evidence of marked rock decay. Disintegration of all the higher peaks and crests is rapid, owing principally to great changes of temperature and the freezing of water in the interstices of the rock. But the debris resulting from this action is rapidly carried away by avalanches and glaciers, so that the crests, as well as the subordinate features in the sculpture of the cliffs and pyramids, are all angular. The subdued and rounded contour, due to the accumulation of the products of disintegration and decay, the indications of the advancing age of mountains, are nowhere to be seen. The St. Elias Range is young, probably the very youngest of the important mountain ranges on this continent. No evidences of erosion previous to the formation of the ice sheets that now clothe it have been observed. Glaciers apparently took immediate possession of the lines of depression as the mountain range grew in height, and furnish a living example from which to determine the part that ice streams play in mountain sculpture. End of section 16. Recording by Jack Daniel, San Francisco, California.
Section 17 of National Geographic Magazine, Volume 3. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. An Expedition to Mount St. Elias, Appendix A. Official Instructions Governing the Expedition. In order to make the records of the St. Elias expedition complete, copies of the instructions under which the work was carried out are appended. Department of the Interior, United States Geological Survey, Geologic Branch, Washington, D.C., May 28, 1890. Mr. I.C. Russell, Geologist. Sir: You are hereby detailed to visit the St. Elias Range of Alaska for work of exploration under the joint auspices of the National Geographic Society and the United States Geological Survey. The Geological Survey furnishes instruments and contributes the sum of $1,000 towards the expenses of the expedition. The money devoted to this purpose is taken from the appropriation for the fiscal year ending June 30th, 1890, and the manner of its expenditure must conform to that fact. The survey expects that you will give special attention to glaciers, to their distribution, to the associated topographic types, to indications of the former extent of glaciation, and to types of subaerial sculpture under special conditions of erosion, and that you will also bring back information with reference to the age of the formations seen and the type of structure of the range. With the aid of Mr. Kerr, it is expected that you will secure definite geographic information as to the belt of country traversed by you. Very respectfully, G. K. Gilbert, Chief Geologist. Approved, J.W. Powell, Director. Department of the Interior, United States Geological Survey, Geologic Branch, Washington, D.C., May 28, 1890. Mr. I.C. Russell, Geologist. Sir: You will proceed at the earliest practicable date to Tacoma, Washington Territory, and thence by water to Sitka, Alaska, at which point you will make special arrangements to visit the St. Elias range of mountains, and make geological examinations as per instructions otherwise communicated. Mr. Mark B. Kerr, Dispersing Agent, will report to you at Victoria, British Columbia, and accompany you on the expedition, assisting you in the capacities of Dispersing Agent and Topographer. On the completion of your work you will return to Washington, the route being left to your discretion, to be determined by considerations which cannot now be foreseen. Very respectfully, G.K. Gilbert, Chief Geologist. Approved, J.W. Powell, Director. Department of the Interior, United States Geological Survey, Geologic Branch, Washington, D.C., May 28, 1890. Mr. Mark B. Kerr, Dispersing Agent. Sir: You are hereby detailed to assist Mr. I.C. Russell, Geologist, who starts at once on an expedition to Alaska under the joint auspices of the National Geographic Society and the United States Geological Survey. It is expected that you will immediately aid him in disbursement, and that you will act during the exploratory part of the expedition as topographer. Your duties will, however, not be limited to these special functions, but you will be expected to perform any other duties he may assign to you, and to labor in every way for the success of the expedition. It is expected that you will be reappointed to the grade of topographer on the United States Geological Survey on the 1st of July, 1890, and you will please take the required oath of office before your departure. The money remaining in your possession as dispersing agent includes that needed to meet Mr. Russell's salary and your own, and also the sum of $1,000 allotted from the funds of the Geographic Branch for expenses of the expedition prior to June 30. This amount you will expend as directed by Mr. Russell, and his authority and certificate will need to accompany your vouchers in rendering account of the same. Very respectfully, G.K. Gilbert, Chief Geologist. Approved, J.W. Powell, Director. Department of the Interior, United States Geological Survey, Geologic Branch, Washington, D.C., May 28, 1890. Mr. Mark B. Kerr, Dispersing Agent. Sir: You will proceed at once to San Francisco, California, and thence by steamer or by rail and steamer to Sitka, Alaska. It is expected that you will join Mr. I.C. Russell, Geologist, at Victoria, British Columbia, or at Sitka, and you will report to him for further orders. Very respectfully, G.K. Gilbert, Chief Geologist. Approved, J.W. Powell, Director. Washington, D.C., May 29, 1890. Mr. Mark B. Kerr, Topographer. Sir: You are hereby assigned to field work in the vicinity of Mount St. Elias, Alaska, in the party under charge of Mr. I.C. Russell. Upon the receipt of these instructions, you will please proceed without delay to the field, and map upon a scale of 4 miles to an inch such territory in the vicinity of Mount St. Elias, including that mountain, as the field season will permit. The work should, if practicable, be controlled by triangulation. Special attention in the course of your work should be given to measuring the altitude of Mount St. Elias, and it should be determined by triangulation and also, if practicable, by barometer in such manner as to be conclusive. The topographic work should be controlled by triangulation. As many positions on this coast are approximately known, including a number of the prominent peaks, astronomical determinations of position will not be necessary unless needed to supplement the triangulation. The details of your outfitting and the management of the work will be left to your own judgment. Very respectfully, Henry Gannett, Chief Topographer. National Geographic Society, Memorandum of Instructions to the party sent out under the direction of Mr. I.C. Russell, assisted by Mr. Mark B. Kerr, to explore the Mount St. Elias region, Alaska, 1890. The general object of the expedition is to make a geographic reconnaissance of as large an area as practicable in the St. Elias Range, Alaska, including a study of its glacial phenomena, the preparation of a map of the region explored, and the measurement of the height of Mount St. Elias and other neighboring mountains. Observations should also be made and information collected on other subjects of general scientific interest as far as practicable. The purpose of these instructions is mainly to suggest the lines of investigation that give promise of valuable results, but it is not intended that they shall limit the direction of the expedition in the exercise of his own discretion. Gardiner G. Hubbard, Chairman; Marcus Baker; Willard D. Johnson, Committee. Washington, D.C., May 29, 1890. End of section 17. Recording by Patti Cunningham. Section 18 of National Geographic Magazine, Volume 3. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. An Expedition to Mount St. Elias, Appendix B. Report on Topographic Work by Mark B. Kerr. In addition to the ascent of Mount St. Elias, it was part of the original plan of the expedition to make an accurate topographic map of the region explored. It was not, however, for this purpose proposed to divide the party or to deviate much from the most direct route to Mount St. Elias from Yakutat Bay. Triangulation of fair precision was provided for. Details were to be filled in by approximate methods. Fieldwork began June 20th by the careful measurement of a base line, 3,850 feet in length, near the point of landing on the northern shore of Yakutat Bay. Expansion was readily carried to the foothills, and several horizontal angles were taken to an astronomical station of the United States coast and the Geodetic Survey at Point Mulgrave. In the region of these initial triangles, work was done from a central camp, and topographic details were fixed with considerable precision by intersection and vertical angles. After the departure of the expedition from the baseline camp, an accident to the transit made resort to an inferior instrument necessary, and furthermore, as the region traversed proved to be ill adapted to, and the line of travel too direct for, the proper development of a narrow belt of triangles, the anticipation of a degree of precision in the triangulation which would give high value to the determinations of position and altitude of the several peaks was not realized. But topographic map work showing the general features, altitudes, and location of the mountain ranges, valleys, and glaciers was extended over about 600 square miles. Within the approximate geometric control, stations were interpolated by the three-point method, and minor locations were multiplied by intersection and connected by sketch. The best meander possible under the circumstances was carried forward on the line of travel by compass directions and estimates of distance from time intervals. The work ceased August 22nd with the abandonment of the instruments in a snowstorm of 4 days' duration on the eastern slope of Mount St. Elias. The accompanying map, a reduction of which forms Plate 8, page 75, shows the ice streams and peculiar mountain topography of a region heretofore unvisited, and constitutes a considerable addition to the geography of Alaska. End of section 18. Recording by Patti Cunningham. Section 19 of National Geographic Magazine, Volume 3. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. An Expedition to Mount St. Elias, Appendix C. Report on Auriferous Sands from Yakutat Bay by J. Stanley Brown. Among the specimens obtained by Mr. I.C. Russell during the course of his explorations on and about Mount St. Elias is a bottle of sand procured from the beach on the extreme southern end of Contact Island, Yakutat Bay, and characteristic of the shore material over a large area. This sand was turned over to me for examination, and additional interest was given to its study by the fact that it is from a comparatively uninvestigated region and possesses, perhaps, economic value. For the sample is gold-bearing, and it is said that a color can be readily obtained by panning at many points on the bay shore. Macroscopically, the sand has the appearance of ordinary finely comminuted beach material, but it differs in the uniformity of the size of its particles from beach sand from Fort Monroe and Sullivan Island, South Carolina, with which it was compared. Its mineralogic constituents greatly surpass in variety those of the sands referred to, but are markedly similar to those of gold-bearing sand from New Zealand. At least 12 minerals are present, with an unusual predominance of one, as will be noted later. Through the mixture of white, green, and black grains, a dull greenish-black color is given to the mass. The roundness of fragments is such as usually results from water action, but it is less than that which results from transportation by wind. When put into a heavy liquid, Thoulet solution at a density of 3.1, in order to determine the specific gravity of the constituents, it was found that the sand is made up largely of the heavier materials, for the amount that floated was trifling compared with that which quickly sank. Even the abundant quartz was largely carried down by the weightier ingredients bound up within it, and only a few water-clear fragments were left behind. This would seem to suggest that the lighter minerals are lacking in the neighboring rocks, or else have been carried to greater distances by the sorting power of the water. Among the minerals recognized, gold is the most important, though relatively not abundant. It occurs in flakes or flattened grains from 1/4 to 1/2 millimeter in size. The particles are sufficiently numerous to be readily selected from their associates by the aid of panning and a hand lens of good magnifying power, and if distributed throughout the beach as plentifully as in the sample would, under favorable conditions, pay for working. The flakes in their rounded character show the effect of the agency which separated them from their matrix, a separation so complete that no rock is found adhering to the grains. Magnetite is present in great abundance and in a finely divided state, the largest grains not exceeding 1 millimeter in length. It forms by weight alone 15 or 20% of the entire mass, and when the latter is sifted through a sieve of 100 meshes to the inch, it constitutes 44% of this fine material. Crystallographic faces are rare, and though often marred, still octahedrons of considerable perfection are found. Garnet occurs in such profusion that a pink tint is given to a mass of selected grains of uniform size, and its predominance may be considered the chief physical characteristic of the sand. 2 species were noted. One is a brilliant wine-red variety, which, though not nearly so numerous as its duller relative, occurs more frequently in crystals, the trapezohedral faces predominating. The other garnet is readily distinguished by its lighter amethystine tint and its greater abundance. Crystallographic faces are somewhat rare and invariably dodecahedral. In the absence of chemical analyses, any statements as to the exact species to which these garnets should be referred would be largely conjectural. Attention is quickly drawn to the perfection of these minute garnets in their crystallographic faces and outlines, and to their association with rounded fragments of their own kind as well as of other minerals. Have these crystals survived by reason of their hardness or by favoring conditions? Or does their preservation suggest the impotency of wave action in the destruction of minute bodies? Among the black heavy grains occur individuals which, except in shape and non-magnetic character, resemble magnetite. On crushing between glass slides, thin slivers are obtained which in transmitted light are green. and which, from their cleavage, pleochroism, high index of refraction, small extinction angle, and insolubility in acid, are readily recognized as hornblende. Two groups of grains were noted, which are distinguishable by slight variation in color. Both are clear yellowish-green, but one is somewhat darker than the other. The optical properties of both indicate pyroxene and possibly olivine. Fortunately, a fragment was obtained in the orthodiagonal zone nearly normal to an optic axis, which gave an axial figure of sufficient definiteness to indicate its optically positive character. A number of grains were selected from minerals of both colors and subjected to prolonged heating in hydrochloric acid without decomposition, indicating that both minerals are pyroxene. A few zircons, a fraction of a millimeter in size but perfect in form, were found associated with others rounded on their solid angles and edges. The crystals are of common short form and bear the usual faces in a greater or less degree of development. Pyramids of the first and second order alternate in magnitude. Pinacoid encroaches upon prism, and vice versa. Quartz constitutes by far the largest proportion of the minerals, both in bulk and in weight. It is always fragmental, sometimes water clear, but chiefly occurs in opaque grains of different colors. It is seldom free from material of a higher specific gravity, and is often so tinted as to be almost indistinguishable from magnetite, but readily bleaches in acid. Feldspar is sparingly present, and includes both monoclinic and triclinic forms, whose crystallographic boundaries are invariably lacking. Treatment of the sand with dilute acid produces effervescence, which is not due to incrustations of sodium carbonate. By persistent search among particles separated in a heavy solution, a few grains were discovered which, from their complete solubility with effervescence in very dilute acid, as well as their optical properties, left no doubt as to their being calcite. The mica group has only one representative, biotite, and this occurs most sparingly, though much of the sand was examined, but few fragments were found. Its foliated character renders it easily transported by water and explains its absence from among the heavy minerals. Shaly, slaty, and schistose material forms the major part of the coarser grains. Thin sections from the largest pieces plainly indicated hornblende schist. A region of glaciers would seem to be favorable not only to the collection of meteoric material, but also to the destruction of the country rocks, the setting free of their mineralogic constituents in a comparatively fresh state, and their transportation to the sea. It was hoped that this sand would yield some of the rarer varieties of minerals, but tests for native iron, platinum, chromite, gneiss, and the titaniferous minerals proved ineffectual. Titanium is present, but in such small quantities that it could only be detected by means of hydrogen peroxide. The use of acid supersulfate and the borotungstate of calcium test of Lascaux failed to reveal the presence of native iron. It will be seen from the foregoing enumeration that the sand is made up of grains of gold, magnetite, garnet, hornblende, pyroxene, zircon, quartz, feldspar, calcite, and mica, associated with fragments of shaly, slaty, and schistose character. While the information at hand is hardly sufficient to warrant much speculation concerning the rock masses of the interior, still there is no doubt that the sand is derived from the deconstruction of metamorphic rocks. End of section 19. Recording by Patti Cunningham. Section 20 of National Geographic Magazine, Volume 3. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. An Expedition to Mount St. Elias, Appendix D. Report on Fossil Plants by Lester F. Ward. Department of the Interior, United States Geological Survey, Washington, D.C., March 12, 1891. Mr. I. C. Russell, United States Geological Survey. My dear Sir, the following report upon the small collection of fossil plants made by you at Pinnacle Pass near Mount St. Elias, Alaska, and sent to this division for identification, has been prepared by Professor F. H. Knowlton, who gave the collection a careful study during my absence in Florida. Previous to going away, I had somewhat hastily examined the specimens, and seen that they consisted chiefly of the genus Salix, some of them reminding me strongly of living species. I have no doubt that Professor Knowlton's more thorough comparisons can be relied upon with as much confidence as the nature of the collection will permit, and I also agree with his conclusions. Quote, "The collection consists of 7 small hand specimens, upon which are impressed no less than 17 more or less completely preserved dicotyledonous leaves. These specimens at first seemed to represent 6 or 8 species, but after a careful study I think I am safe in reducing the number to 4, as several of the impressions have been nearly obliterated by prolonged exposure and cannot be studied with much satisfaction. The 4 determinable species belong without much doubt to the genus Salix. Number 1, of which there is but a single specimen, I have identified with Salix californica Lesquereux, from the auriferous gravel deposits of the Sierra Nevada in California. The finer nervation of the specimens from the auriferous gravels is not clearly shown in Lesquereux's figures, nor is it well preserved in the Mount St. Elias specimens, but the size, outline, and primary nervation are identical. Number 2, of which there are 6 or 8 specimens, may be compared with Salix raeana here, a species that was first described from Greenland and was later detected by Lesquereux in a collection from Cook's Inlet, Alaska. The Mount St. Elias specimens are not very much like the original figures of here, but are very similar in outline at least to the species as figured by Lesquereux. They are also very similar to some forms of the living S. rostrata Richardson with entire leaves. It is clearly a willow, but closer identification must remain for more complete material. Number 3, represented by 4 or 5 specimens, is broadly elliptical in outline and is also clearly a Salix. It is unlike any fossil form with which I am familiar, but is very similar to the living S. nigricans, 4 var. rotundifolia, and to certain forms of S. siliciaca wild. The nervation is very distinctly preserved, and has all the characters of a willow leaf. Number 4, represented by 3 or 4 very fine specimens, is a very large leaf measuring 13 centimeters in length and 3½ centimeters in width at the broadest point. It may be compared with Salix macrophylla here, but it cannot be this species. It is also like some of the living forms of S. nigra Marsh, from which it differs in having perfectly entire margins. While it is manifestly impossible on the basis of the above identifications to speak with confidence as to the age or formation containing these leaves, it can hardly be older than the Miocene, and from its strong resemblance to the present existing flora of Alaska, it is likely to be much younger. F. H. Knowlton. End quote. Very sincerely yours, Lester F. Ward. End of section 20. Recording by Patti Cunningham.
Section 21 of National Geographic Magazine, Volume 3. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Cartography and Observations of Bering's First Voyage by General A. W. Greely, Part 1. Presented before the Society, March 20, 1891. It was with no ordinary pleasure that the members of the National Geographic Society listened to the critical review and admirable essay on Bering's first expedition, 1725 to 1730, read before this society, together with a translation of Bering's report on the expedition in question by one of our learned and distinguished members, Professor William H. Dall. The subject then under consideration is one of great interest, and this society owes a debt of gratitude to Professor Dall for his assiduous labor in collating and translating the available data on this voyage, and must endorse the general conclusions reached in a critical essay which is the result of careful, conscientious research conjoined to much erudition. It is especially fortunate in view of the vagueness of Bering's report that it should have been translated and reviewed by a traveler and investigator so thoroughly familiar with the topography of Bering Strait and the adjacent region. It may appear somewhat presumptuous for the present writer to further dwell on some points of subordinate importance, even with the view of supplementing the investigations of Professor Dall, but he is encouraged to the effort by the admirable spirit in which that gentleman works, which is so clearly indicated in his own words, quote, "I am well aware this paper cannot be regarded as a finality, but as a contribution to the geographical history of North America it will not be without its value." Unquote. This spirit encourages everyone to contribute his mite to elucidate the history of this interesting and ill-known period. The supplementary remarks now presented mainly relate to 2 points. First, the cartographic reproduction of Bering's discoveries. Second, the alleged observations of lunar eclipses in Kamchatka by Bering and his lieutenants in 1728 to 29. In attempting to add to Professor Dall's essay or to elucidate some points, it is but natural to felicitate one's self that chance has put in one's way rare data in the shape of text and map. Nevertheless, much difficulty has been experienced in efforts to consult publications and charts bearing on this subject as supplementary to the data in the writer's own library. Fortunately, among his personal books and maps are the following, which have escaped the critical, if not casual, observation of Professor Dall. 1. The original Hague edition of Père du Halde, which Dall was unable to consult. It is entitled Description géographique, historique, chronologique, politique et physique de l'Empire et de la Tartarie chinoise, etc. 4 volumes, quarto, Allaye, 1736. 2. Delisle's scattered essays entitled Mémoire pour servir à l'histoire et au progrès de l'astronomie, de la géographie et de la physique, etc., etc., à Saint-Pétersbourg, de l'imprimerie de l'Académie des sciences, 1738. 3. Atlas russien, contenant une carte générale et 19 cartes particulières de tout l'Empire de Russie et des pays limitrophes construites conformément aux règles de la géographie et aux dernières observations, par l'Académie impériale des sciences de Saint-Pétersbourg, Saint-Pétersbourg, 1745. This was the first atlas published in Russia, in the map department established by order of Peter the Great in the Academy of Sciences of St. Petersburg. It includes a general map of the Russian Empire and 19 maps of provinces. 4. Carte de la Sibérie et des pays voisins, pour servir à histoire générale des voyages par les Espelines, ingénieurs de la marine. 2 parts, undated, but to which E. Dufosse of Paris assigns the date of 1749. The atlas for this work was originally published by Abbe Prévost at Paris, 1747, at Sig, the charts being engraved by Bellin. This chart appears on casual inspection to be more accurate than either that of D'Anville or of Delisle or of the Russian atlas. 5. The very interesting and valuable map of J.N. de Lisle, Paris, 1752, without, however, the accompanying memoir. I do not think the original map has ever fallen under the notice of Professor Dall, although a garbled reproduction of it is mentioned in his review as follows, quote, "A chart which deserves notice, though almost wholly fictitious, being chiefly devoted to the spurious discoveries of the alleged Admiral de Fond, was issued by J.N. de Lisle with the concurrence of M.P. Bosch, or at his suggestion. It appeared at Paris in 1752, and was copied for Jeffrey's second edition of Voyages from Asia to America in 1764. I do not know if this copy appeared in the first edition, but presume it did." Unquote. As the original of de Lisle's chart, 1752, is here exhibited tonight, it is evident that Jeffrey was careless, and that the map, which I infer Dall has never seen, is really more valuable than is set forth in his address. Otherwise, so critical an observer as Dall would not have said, quote, "I suspect this," referring to D'Anville's map of 1753 with Bering Island thereon, "is the first publication of a cartographic kind on which Bering Island is laid down as the map of the Imperial Academy of Sciences embodying the geographical results of Bering's voyage to the coast of America was not engraved until a year later, while de Lisle's of 1752 does not contain them." Unquote. You will see that this is an error, for the Île de Bering is plainly inscribed on the map. This map has been reproduced by photolithography and forms the accompanying plate 21. Dall further describes the copy of this map in the following terms. Quote, "Connected with America and north of the Chukchi Peninsula is land with an island off it, corresponding not badly to Wrangel and Herald Islands, and marked discovered in 1722. It is possible that this land is a hypothetical compound of the land reported by the Chukchis east of the strait, with that which they knew to be visible in clear weather from Cape Yakan, more or less confused accounts of which had long been current among persons interested in these regions." Unquote. The legend on the original chart indicates that Dall's surmise is correct, for the copy is not only abbreviated, but is in error as to date. On the original it runs Grande terre découverte en 1723 au Saint-Feuille les Tsutsi, lorsqu'ils sont poursuivis par les Russes qui ne les ont pas encore soumis. There is another important legend on a very large imaginary island about 5 degrees of longitude to the east of Bering Island. On the northern side of this land the text runs thus: Terre dont le capitaine Bering sa en descendit dans son premier voyage en 1728. On the northern edge is the legend: Côte vue par Monsieur Chirikov et de Lisle en septembre 1741. Immediately south of the land are 2 route tracks with these legends: Route du Kamchatka à l'Amérique par les capitaines Chirikov et Monsieur de Lisle de la Croyère en juin et juillet 1741. Retour de l'Amérique au Kamchatka en août et septembre 1741. The latter route track touches an indentation in the southwestern coast, as though the vessel had entered the bay, which has 5 mountains in the background. The legend Terre vue par les Russes en 1741, où le capitaine Chirikov perdit sa chaloupe armée de 10 hommes, is likewise of interest, as controverting the statement that de Lisle's chart of 1752 does not contain the geographical results of Bering's voyage to the coast of America. It embodies a large part, but not all, of the discoveries. 6. Bois's memoir and maps entitled Considérations géographiques et physiques sur les nouvelles découvertes au nord de la Grande Mer, appelée vulgairement la mer du Sud, avec des cartes qui y sont relatives, par Philippe Bois, premier géographe, etc. À Paris, 1753. Quarto, 158 pages. With my copy, there is a separate pamphlet consisting of 13 maps, folio, with a preface and index, quarto. The preface, quarto, 2 leaves unpaged, is entitled Exposé des découvertes au nord de la Grande Mer, etc., etc., présenté au roi le 2 septembre 1753 par Philippe Boache, etc. The index, quarto, 4 pages, runs Liste des cartes concernant les nouvelles découvertes au nord de la Grande Mer, etc., par Philippe Boache, etc., janvier 1755. These 13 maps are very interesting. The first and second charts bear particularly on the subject of this paper. The first is entitled Carte de nouvelles découvertes entre la partie orient de l'Asie et le sud de l'Amérique avec des vues sur la grande terre connue par les Russes en 1741, etc., etc. Dressé par Philippe Boache, présenté à l'Académie des sciences le 9 août 1742 et approuvé dans son assemblée du 6 septembre suivant. This map, somewhat fuller in details than that of Delisle, shows découverte des Russes depuis 20 ans. There are route tracks of the first expedition marked Route des Russes au nord-est et au nord en 1728 et 1731 and Retour en 1731. 2 route tracks of the later voyage have the legends Route de Kamchatka à l'Amérique en 1741, Retour des Russes au Kamchatka. Other legends are as follows. Île Bering, Détroit du Nord, Bering Strait. Terre découverte en 1723 par les Russes, ou île dont le avril à parle. Large land near Wrangel Island. Terre reconnue par les Russes, American coast in latitude 56 degrees north. Côte vue par les Russes en 1741, port où les Russes ont à bord. Fictitious and extensive land east of Bering Island, on which are also the following Puchotske, Salon, Stralenberg, and terre habitée ou presqu'île que je suppose joindrait les couvertes des Russes avec celle de l'âme de fond. The second map, carte découverte de la malle de fond avec les terres vues et reconnues par les Russes, par Philippe Boache, has other pertinent and interesting legends. In Bering Strait appears Bering a trouvé au nord et à l'est de ces parages que la mer y étoile libre. And immediately eastward on the American coast, below the parallel of the Arctic Circle, terre découverte en 1731, et où les Russes ont rencontré un homme qui s'est dit habitant d'un grand continent. On the American coast, from 55 degrees to 57 degrees north latitude, terre découverte en juillet 1741, et où les Russes ont laissé 10 hommes qu'ils n'ont pas rejoindre. Over terre habitée, a large land just east of Bering Island, le capitaine Bering a trouvé dans ces parages de 50 à 60 degrés les indices d'une côte et d'une grande rive où il a envoyé quelques hommes qui ne sont revenus. It is evident that those maps must have been actually published as early as September 2nd, 1753, the date on which was presented the Exposé des découvertes, etc., au roi, but the charge gave no further indication than the legend publié sous le privilège de l'Académie royale des sciences du 6 septembre 1752 à Paris. The actual date of issue may or may not have been earlier than the map of Delisle of September 9th, 1752. 7. Possibly most important of all, a letter of an officer of the Russian Navy. This appeared first in Russian presumably printed at St. Petersburg in 1752 or 1753. The original Russian I have not seen. It was translated, however, into French and printed at Berlin, not dated, in 1753, under the following title: Lettre d'un officier de la marine russienne à un signor de la cour concernant la carte de nouvelles découvertes au nord de la mer du Sud et les mémoires qui y cèdent d'explication. Publié par M. Delisle à Paris en 1752. Traduit de l'original russe à Berlin chez Odette Sperrer, libraire de la cour et de l'Académie royale, 1753. This edition forms part of my library and is the only copy which I know of in the United States. It is not to be found in the Library of Congress, the Astor Library, the Boston Athenaeum, or the Boston Public Library. It is not even in the Royal Library of St. Petersburg, but, as might be anticipated, is in the British Museum. I find it nowhere catalogued in any bibliography of Arctic or subarctic works. The French edition was inserted with some changes, it is believed, in the 18th volume of the Nouvelle Bibliothèque Germanique. 8. A letter from a Russian sea officer to a person of distinction at the court of St. Petersburg, containing remarks on Mr. Delisle's chart and memoir relative to the new discoveries north and east from Kamchatka, together with some observations on that letter by Arthur Dobbs, governor of East Carolina, to which is added Mr. Delisle's explanatory memoir on his chart. Octavo, 85 pages, London, 1754. The Arthur Dobbs, who published this edition, and who possibly was a translator thereof, is well known as the energetic promoter of the discovery of the Northwest Passage, and was personally interested in discovery voyages to Hudson Bay. The explanatory memoir of Delisle's chart is a translation of the memoir previously mentioned as belonging to the map of 1752, which memoir I have not been able to consult in the original French. It may be added that Dobbs' reproduction of the letter from a Russian naval officer is not accurate, the translation in places being so carelessly or indifferently made that the text cannot be relied on for critical purposes. This English translation is to be found neither in the Library of Congress, the Boston Public Library, the Boston Athenaeum, nor in the Library of the American Geographic Society. It is, however, in the Astor Library, and a second copy at one time belonged to the library of Mr. J.C. Brevoort. 9. Map Monde, Carte universelle de la Terre, par J.B. Nolan, Geographe. 1755, 20 1/4 to 27 inches. On this appear the legends: Île de Bering, Détroit du Nord, terre découverte par les Russes en 1741, terre vue en 1741. It is quite possible that this is the first map of the world on which Bering Island was charted. 10. John Christopher Adelung's very interesting history of sea voyages for the discovery of a northeast passage, which was published in quarto form under the following title: Geschichte der Skifahrten und Versuche, welche zur Entdeckung des nordöstlichen Weges nach Japan und China von verschiedenen Nationen unternommen wurden. Zum Behufe der Erdbeschreibung und Naturgeschichte dieser Gegenden, entworfen von Johann Christoph Adelung, herzoglich Sachsichen Rathalle bei Johann Justinus Gebauer, 1768. 11. Notice des ouvrages de Monsieur Danville, octavo, Paris, 1802, 120 pages, by Barbic du Bocage. In addition to these and other works from my own collection, I have consulted the Library of the United States Naval Observatory in this city, Histoire de l'Académie Royale des Sciences, année 1750, Paris, 1754, and the same, année 1754, Paris, 1757, which contain articles on Delisle's manuscript maps of 1731 and 1752, the latter being substantially identical with the published map of 1752. From Dall's Review, we learn that Lauridsen is responsible for the statement that the discoveries of Bering in his first voyage were shown on a chart made at Moscow in 1731, but no authority is given as to the cartographer. Later I shall adduce evidence to confirm Dall's opinion that the Moscow map was merely a copy, such as were distributed to personages of importance or to those connected with the expedition. It is further susceptible of, as I think, tolerably satisfactory proof that the outlines of Kamchatka, with fairly correct meridians of longitude, were made public in a chart by de L'Isle, not in 1731, but the year following, 1732, and it is likely that the lost map of that year was substantially reproduced in the chart of 1752, which I have the pleasure of now presenting for your examination. De L'Isle presented this map to the Academy of Sciences of Paris on April the 8th, 1750. The circumstances connected with the presentation have been drawn from the official records of the Royal Academy of Sciences and are as follows. Cette année, 1750, M. de L'Isle lut à l'Assemblée publique de l'Académie un mémoire sur les nouvelles découvertes au nord de la mer du Sud, et présenta en même temps une carte que M. Voyage a redressée sur ces mémoires et qui représentera ces découvertes avec toute la partie du globe terrestre à laquelle elles appartiennent. Ces ouvrages alors manuscrits furent depuis publiés en 1752. M. Voyage présenta dans cette même année la première partie de ses considérations géographiques sur les mêmes sujets avec les cartes qui y étaient relatives. Muni de ces premières connaissances, referring to the discoveries of 1729-1739, M. de L'Isle traça une carte qui représentait l'extrémité orientale de l'Asie avec la partie opposée de l'Amérique septentrionale qui y répond, afin de faire voir aisément ce qui restait à découvrir, et il dressa une mémoire dans laquelle il exposa la manière qu'il jugea la plus avantageuse pour faire ces découvertes. Mais les vaisseaux russes qui avaient été envoyés pour les découvertes dont nous venons de parler, 1731, 1741, n'étant pas encore revenus lorsqu'elle lui fut envoyée, il extremit l'examen après son retour en France, qui était assez prochain. À son arrivée, il communiqua ses vues et cette relation à M. Voyage, celui-ci qu'il parla, etc., etc. Cette mémoire, de L'Isle, 1750, était accompagnée d'une carte qui était comme l'esquisse du système géographique de M. de L'Isle sur cette partie. It has been pointed out by several authorities that some of M. de L'Isle's statements in his memoir of 1752 are to be received with caution, especially his elaborate endeavors to impress the Paris Academy with the belief that the discoveries of Bering subsequent to the first voyage were the result of his, de L'Isle's, own carefully considered instructions. In this connection, Adelung says, quote, de L'Isle, in his Explication de la Carte des Nouvelles Découvertes au Nord, 1752, traces out his proposed route quite differently, referring to de L'Isle's previous statements in his report to St. Petersburg Academy in 1732, somewhat as if it had been outlined in view of accomplished facts. Unquote. It behooves us, then, to inquire carefully into the authenticity of the alleged map of de L'Isle of 1731, since, if he antedated his opinions as to the route, he might also have antedated his map. Fortunately, we do not have to depend only on de L'Isle's own statement, either in 1750 before the Academy of Sciences at Paris, or as published in 1738 at St. Petersburg and printed at the printing office of the Royal Academy, for we also have extraneous and convincing evidence, even from sources critically hostile to the French astronomer. M. de L'Isle, in his Memoires sur les nouvelles découvertes au nord de la mer du Sud, Paris, 1752, says, quote, After I had, nearly 20 years ago, got these first informations of the longitude of Kamchatka by means of Captain Bering's map and journal, I made use of them in constructing the map representing the eastern extremity of Asia with the opposite coast of North America, in order to show at once what still remains for discovery between two large parts of the world. This map I had the honor of presenting to the Empress Anne and the Senate, in order to animate the Russians to undertake these discoveries, and it took effect, this princess ordering a second voyage to be made according to the plan which I had drawn up for it." Unquote. 2 maps, he adds, were presented to the Academy in Paris, "one being a copy of the map which I had drawn at St. Petersburg, 1731, on Captain Bering's first voyage, and had the honor of presenting to the Empress Anne and the Senate with a manuscript memoir explaining its use and construction." Unquote. The other map, from which the lithograph before you was lately reproduced, was according to de L'Isle only changed by adding the later discoveries of Bering and his lieutenants. De L'Isle further says of this chart, "The second manuscript map, which I laid before the Academy at Paris, was in all respects like the former, only with the advantages of the new discoveries made since 1731." Philippe Boisch, the French geographer, made for de L'Isle a reduced copy of the second chart, and it is supposed that the map before you is a substantial reproduction of that copy. In the preface to de L'Isle's Scattered Essays, 1738, St. Petersburg, page 2, we find, Ayant comparé la situation du Kamchatka et des pays voisins avec celle de la Chine, du royaume de Corée, du Japon et de la terre de Yeko, qui m'étant connu de lors, je me suis fait un système et j'ai dressé l'an 1731 une carte de cette extrémité orientale de l'Asie. J'ai marqué aussi sur cette carte les dernières terres connues de l'Amérique, les plus voisins de cette partie septentrionale de l'Asie, afin de faire voir ce qui restera encore d'inconnu entre deux. On trouvera dans ce recueil une réduction de cette carte avec les mémoires que j'ai dressées dans ce thème-là, lus à l'Académie, dans lequel je rends raison de la construction de cette carte. Unquote. Only one volume of de L'Isle's essays appeared, so that the map and memoir promised in the introduction were never, so far as can be learned, published in their original form. The statements made by de L'Isle, however, unless definitely refuted, should be given full credit, seeing that the work was published by the Academy of Sciences at St. Petersburg, to which the map and memoir were presented, as is claimed, only 7 years earlier. A doubt does, however, exist as to the date of the map made by de L'Isle. On this point, Adelung, in his History of Northeastern Voyages, Hall, 1768, page 569, evidently quoting from Müller, says, "On the 17th of April, 1732, the order was, therefore, sent from the Privy Cabinet to the Senate, which thereupon inquired of the Academy of Sciences of St. Petersburg what and how much had as yet been found out about Kamchatka, the surrounding countries and waters. The Academy confided the making of the report to Mr. de L'Isle, who prepared a chart upon which Kamchatka, Jesso, according to the description of the crew upon the Castricom, the Staten Island, Company Island, and the coast of Gama were designated. This chart was supplemented by a memoir in which he described the discoveries already made and suggested various routes for making new ones. He expressed himself in regard to those routes in the following manner: If one have attained the northern boundary of Asia, and at the same time the eastern limits as far as Captain Bering went on his first voyage, one cannot fail to arrive in America, and might even choose the route either northeast or southeast, whichever he prefers, as he would have at most only 600 miles to pass over. 2. Or, without venturing so far, it would perhaps be better and more comfortable to sail from the east coast of Kamchatka, go directly east, to look for the neighboring country which Bering found traces of in his first voyage. 3. Finally, he thought that if they should sail northeast from Kamchatka, they would perhaps more speedily and more certainly discover the country seen by Juan de Gama." Unquote. Can the inconsistency between the dates as given by Müller and Adelung on the one hand and by de L'Isle on the other be reconciled, or is it apparent rather than real? As Bering, according to the Russian marine officer Waxel, returned to St. Petersburg on March the 1st, 1730, it is reasonable to suppose that de L'Isle, whose duties were those of a cartographer, had finished within the next year and a half his reproduction of Bering's working chart. The fact that the order of inquiry about the results of the voyage did not leave the Privy Council until April the 17th, 1732, does not necessarily indicate that the map at least, if not the memoir, was not already prepared, even if not in possession of the Academy of Sciences. It appears probable that the map may have been drawn by de L'Isle in 1731, but it is quite certain that it was not made public until 1732. Lauridsen speaks of a map in Moscow in 1731, and, as it is evident from Lauterdun that there was no difficulty in persons of influence procuring copies from the Senate, it is likely that the Moscow chart was a copy of the map of de L'Isle and that the date of 1731 is correct, but this theory must rest on Lauridsen producing evidence that such a map existed in Moscow in 1731. The Russian officer speaks with authority as to the map of 1732. Commenting on de L'Isle's account of the circumstances under which he compiled the map of 1732, he continues as follows, quote, "The Empress Anne, having directed her Senate to give instructions to Mr. Bering for the second voyage, that body believed that it could not act with success unless it obtained from the Academy the fullest information relative to the situation of the lands and seas to be traversed. Therefore the Academy was so ordered by the Senate, which enjoined on M. de L'Isle the construction of the map of which I speak, and, for a clearer understanding, the explanatory memoir, which being done, both map and memoir were presented to the Academy by the Senate. Consequently, there is no reason to doubt that, far from exciting the Russians to new discoveries, far from being the cause of Bering's second voyage, M. de L'Isle only worked under specific orders. It is quite another question whether or not the memoir contributed to the success of the expedition, which I will discuss later. However that may be, the Senate gave a copy of it, as well as of the map, to Mr. Bering. I took a second copy of the memoir, which enabled me to compare it with what M. de L'Isle has now said to us of it in his later memoir of Paris." Unquote. These and other statements confirm those of de L'Isle as to the date of the map. In which year d'Anville engraved it, 1732 or 1731 at the earliest, and likewise indicate that copies of both map and memoir were obtainable without great difficulty. An interesting note as to the authenticity and origin of the chart of d'Anville, 1737, appears in the narrative of Adelung, who speaks with a certain air of authority. He says, quote, "These Bering maps were, after the captain's return, sent from Russia to the King of Poland, who presented them to Mr. Du Halde, or rather to Mr. d'Anville, who made the charts for his work. Du Halde is therefore very correctly informed when he, in the Mémoire de Trevoux, 737 pages, 2,389 francs, considers these charts questionable and imagines that they were merely made by d'Anville from Bering's journal." Unquote. But further evidence from an unquestionable source is available as to date. The charts in Du Halde's China were engraved between the years 1729 and 1734, and all but the general maps were completed prior to 1733. The date 1732 is assigned by d'Anville's colleague to the map of Bering's journey. Of these maps, it is further said, quote, "They form what is commonly known as d'Anville's Atlas of China. Nevertheless, this geographer did not participate equally in the production of all. The detailed maps, of which the Bering map is one, were furnished by the Jesuits, and he only supervised the engraving, but the general charts were entirely the work of d'Anville, who reconstructed and amplified them from all possible sources. They were reproduced at Hague under the title New Atlas of China, etc., by M. d'Anville." Unquote. These statements of d'Anville's colleague, M. Barbic du Bocage, are thus verified by du Halde, page 69. Quote, "Pour le cas général, nous y avons peu touché et celle du voyage du capitaine Bering parois sans les moindres changements." Unquote. In the Russian Atlas 1745, the explanatory text regarding map 19, whereon appears the extreme northeastern coast of Siberia and the greater part of Kamchatka, runs as follows. Quote, "We have determined the location of these provinces in part by astronomical observations which have been made there, and in part upon certain geographical and hydrographic maps which have been transmitted to us." Unquote. So far as Kamchatka and the Bering Strait regions go, it is reasonable to believe that this chart, since it was published by the Royal Academy of Sciences, is substantially a reproduction of the map transmitted to the Academy by de L'Isle in 1732, especially as this geographer was employed for about 13 years in amassing data for the atlas in question. The writer has very carefully compared the chart of Kamchatka and adjoining regions as published in d'Anville's Atlas of 1736, in the Russian Atlas of 1745, and in the de L'Isle chart of 1752. From comparisons, he is led to believe that these maps have substantially the same basis, that is, the chart prepared by de L'Isle in 1732 for the Academy of Sciences, St. Petersburg. In this connection, the criticism of the Russian officer is significant. He says, quote, "I will now finish with a general observation about the part of Siberia that we see on M. de L'Isle's chart, 1752. It is simply a copy of the Russian Atlas, 1745, without even corrections of the errors of drawing and writing which have crept into the work." Unquote. Elsewhere he adds, quote, "We can correct the error of M. de L'Isle, who places Bering Island at 54 degrees, only a short distance from Avacha, whereas it is on the 56th parallel, 60 miles off Avacha, and 40 Dutch miles from the mouth of the Kamchatka River." Unquote. It is worthy of note that on Bellin's map of 1749, Bering Island is crossed by the 56th parallel of latitude, and that along the southern edge of the Arctic Ocean is a route track marked Voyage fait par mer en 1248 par 3 vaisseaux russiens dont un est parvenu à la Kamchatka. On de L'Isle's chart of 1752 also appears the route of 1648, but Bering Island is in latitude 54 degrees. As to the position of Bering Isle, the truth, as the wise man tells us is oft the case, abides between the two, as the 55th parallel intersects the land in question. At Cape Shelagskoy, d'Anville, 1737, the Russian Atlas of 1745, and the de L'Isle of 1752 agree in charting 4 islands northeast of the Cape instead of 2 islands to the west. This indicates a common origin to the charts, and where else can it be ascribed than to the de L'Isle map of 1732? The Russian officer, however, gives a clue as to the date when work on the map was commenced. He says, quote, "At that time I visited M. de L'Isle. I was a witness of his geographical labors as far as they had new discoveries for their object. I acted as interpreter to Mr. Bering in the conversations which he had with him, and I can assert positively that when M. de L'Isle began that chart, the second expedition was already ordered, and Captain Bering, knowing what was still wanting to his discoveries, offered to continue them and his lieutenants with him, and they received promotion in consequence." Unquote. Lauridsen says, quote, "On January the 5th, 1732, the Senate gave him leave of absence to go to St. Petersburg. Almost simultaneously he was promoted, in regular succession, to the position of Captain Commander in the Russian fleet, the next position below that of Rear Admiral." Unquote. This indicates that the expedition was decided on at least as early as January the 5th, 1732, possibly earlier. Fortunately, we are not left to inference, for elsewhere the Russian officer says, quote, "Mr. de L'Isle throws discredit on our discoveries by leaving on his chart the fictitious land of Gama, which, in order to avoid conflicting with our accounts, he places, in 1752, a little more to the west and south than he did on his chart of 1732." Unquote. This definitely fixes the year in which Delisle presented the map to the Senate. We learn, however, from Lauridsen that, quote, "as early as April 17th, 1732, the Empress ordered the Bering's proposition should be executed and charged the Senate to take the necessary steps for that purpose. On May the 2nd, it, i.e. the Senate, promulgated 2 ukases in which it declared the objects of the expedition and sought to indicate the necessary means." Unquote. It is very improbable that, in the case of so dilatory a man as Delisle, this chart could have been elaborated and drawn, the memoir written, a report made by the Academy to the Senate, and action be taken in the 15 days which elapsed between the order for the chart and Bering's instructions. It is possible that the chart was drawn at the end of 1731, and that Delisle, for obvious reasons, gave it the earliest possible date. In giving an account of Bering's provisions, as Dahl says, every historian has followed a mutilated, if not garbled, paragraph from Bering's original report. The excerpts from Brooke's translation of Du Halde, which was followed in Campbell's edition of Harris's Voyages, are as follows. Quote, "The provisions consisted of carrots for want of corn, grain or wheat, the fat of fish, uncured, served instead of butter, and salt fish, supplied the place of all other meats. Fish oil was his butter, and dried fish his beef and pork. Salt he was obliged to get from the sea. He distilled spirits from sweet straw." Unquote. It appears from Bering's own journal, as well as from Du Halde's account, that in 1727 Bering ordered one of his officers to endeavor to deliver to the command at Kamchatka some part of the provisions, iron and tar. Bering himself said that he was obliged to use tar made from the native spruce, quote, "since the tar which we should have brought with us had not arrived." Unquote. This is confirmed by the additional note in Du Halde, which says that the provisions, iron, pitch, and tar did not arrive till 1728, conveying the inference that it came too late to be of service. Bering appears to have had on July 3rd, 1727, 2,300 poods of flour, equal to about 8,300 pounds, which would be less than a year's supply for his entire party. I cannot agree with Dahl that Bering had plenty of flour or meal and meat. I have said, from Bering's own report, because it seems incredible that Du Halde did not have a transcript of Bering's report, since his narrative, Du Halde's, follows almost word for word Dahl's translation. It is not surprising that different transcripts should differ slightly on unimportant matters. However this may be, it is evident that Brooke's translation of Du Halde's is careless. For instance, in Brooke's translation, edition London, 1736, of Du Halde, on page 430, the number of Bering's party should be 33 instead of 30, and on page 440, where the voyage from Ochotsk to Tatutski is given as from July 23rd to October 2nd, the first named date should be July 29th. Dahl doubts that carrots were of Bering's provisions. Brooke omits the italicized words of Du Halde's narrative, page 567, Lae, 1736. Les provisions consistent en carottes et en racines. As indicated by context, the roots were radishes and turnips. The word carrots is explained by a passage in Greaves' Kamchatka as follows. Quote, "The Markovi pushki, or carrot bunches, are so called because they are like carrots in their leaf as well as in taste. They likewise eat this green in the spring, but they oftener sour it, like sauerkraut, or make a liquor with it." Unquote. Doubtless Bering took these carrot bunches with him. End of section 21. Section 22 of National Geographic Magazine, Volume 3. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Cartography and Observations of Bering's First Voyage by General A. W. Greely, Part 2. Another question which has engaged my attention is that concerning the lunar eclipses which Bering or his party is said to have observed in the winter 1728-29. Dahl says, quote, "In none of the published reports of the expedition is any mention made by Bering or his officers of the occurrence or observation of an eclipse. However, Middendorf states that Bering and his lieutenants in the years 1728 and 1729 observed in Kamchatka 2 eclipses of the moon, by which they corrected the longitude. He gives," says Dahl, "no authority for this statement, and it is probable that an eclipse observed at Ilimsk, in Middle Siberia, by Chirikov, is thus erroneously referred to." Unquote. Mr. Marcus Baker, in a paper appended to Dahl's account, makes it evident that such eclipses, if any, were those of February the 25th, local calendar, 1728, or February the 24th, 1729. My own investigations confirm the statements of Middendorf, and in support of this I refer to de L'Isle and to the author of the letter. In this connection, however, we have the clear and definite statements of de L'Isle, both in his essays of 1738 at St. Petersburg and his memoir of 1752 at Paris. These statements are fully confirmed by the evidence of the Russian marine officer, who certainly served with Bering in his later expeditions, if not in the first, and whose familiarity with all the records and papers should have enabled him definitely to contradict de L'Isle on the main question instead of correcting him in details. In his St. Petersburg Memoirs of 1738, page 10, de L'Isle writes, quote, "On verra à cette occasion la situation de Kamchatka déterminée par 2 éclipses de lune que monsieur le capitaine Bering et Riggan y sont observés dans leur premier voyage, the expedition 1725-30, et dont j'ai rendu compte à l'Académie aussitôt que ces observations m'ont été communiquées." Unquote. In the paper of Paris 1752, Nouvelle découverte au nord de la mer du Sud, de L'Isle says on this point, quote, "Captain Bering and his lieutenant likewise took observations at Kamchatka of 2 eclipses of the moon in the years 1728 and 1729, which helped me to chart the longitude of that eastern extremity of Asia with all the precision which the nature of these observations, made by seamen and with their own instruments, would admit of. But these first determinations have been since confirmed by observations on Jupiter's satellites, taken in that place with the utmost accuracy by my brother and some Russians conversant in this kind of observations, and who were provided with the best of instruments." Unquote. It appeared to me possible that the report on the eclipses of the moon made by de L'Isle to the St. Petersburg Academy of Sciences might be traced up among the archives of that society. In searching for information on this point, it was learned from Mr. O. Fassig, librarian of the Signal Office, that among the unpublished manuscripts in the Pulkova Library, St. Petersburg, were a number by de L'Isle. A list of the manuscripts of Monsieur de L'Isle was compiled and published in 1844 by the distinguished astronometer O. Struve, and among the number is one entitled Observations pour la longitude du Kamchat du 5 occulte aussi de Tobolsk, 1729 manuscript. It was reasonable, in view of de L'Isle's statements in 1738, to suppose that this is the report made to the Academy by him as soon as the observations were furnished him. I had hoped to present with this sketch definite information on this point, since a kinsman of the collator of the manuscript, I refer to the very distinguished representative of Russia to the United States, Mr. de Struve, most courteously offered his valuable mediation in the matter. Unfortunately, I have as yet no further information, but I expect a communication as to the contents of the manuscript at an early day. Criticizing the memoir of de L'Isle of 1752, the Russian officer ridicules the author for speaking of Kamchatka as a town, but he adds, quote, "It is certain likewise that Mr. Bering and his lieutenant, Mr. Chirikov," quoting from de L'Isle's memoir of 1752, had in the years 1728 and 1729 observed at Kamchatka 2 eclipses of the moon, but that by these observations M. de L'Isle was unable to determine the longitude of this most eastern part of Asia with such precision that the same had been confirmed in the second expedition by precise observations of the satellites of Jupiter is what I cannot well conceive. Mr. de L'Isle himself intimates that Messrs. Bering and Chirikov were not provided with astronomical instruments. They observed both these eclipses by the help not of pendulums but of their watches, without being able to know whether they went right or wrong, which makes it almost incredible that a determination based on these 2 eclipses should exactly agree with that deduced from the observations of Jupiter's satellites." Unquote. The officer, from his own account, served with Bering. In the introduction to Une Lettre, he says, quote, "The orders of Your Excellency," to whom the letter was addressed as written by his orders, "will be complied with by me with more than one inspiring motive, and I shall not dwell on my unfitness, although I could find excellent pretext for such an excuse, inasmuch as many of greater experience and equal application participated with me in the discoveries which resulted from the 2 voyages, called by us the Kamchatkan expeditions. The only grounds on which preference could be shown me over them arise from my being charged, after my return from America, with a comparison of the journal of the various vessels together and with whatever was elsewhere to be found relative to lands situated in the South Sea, in order to therefrom construct a map which should accurately represent them all." Unquote. This officer, then, should be the very best authority on this question, especially as he gives details, is always exact in his dates, and sets no value on the observations. Whether or not such observations of lunar eclipses took place, these extracts tend to confirm Dahl's opinion that they serve no purpose in determining the longitude of Kamchatka. The letter and its author are worth some attention at our hands. As has been said, it was published anonymously, and I do not know that its authorship has ever been traced. It appears from the letter that the writer was an officer of the Russian Navy, that he was a Russian, that he was on familiar terms with both Bering and de L'Isle, that he acted as interpreter between them in 1730 to 1731, that he was with Bering in his last voyage to America, and was one of the shipwrecked mariners on Bering Island, and that on his return to St. Petersburg he was charged with the compilations from the various ship journals. As the naval officer states he was with Bering on Bering Island, it is evident that it must have been either Sven Waxel, Sofron Chitrov, or Steller, the well-known scientific professor serving with Bering's expedition. It could not have been Steller, since the professor was a German, and moreover he died in November 1746, prior to the date of the letter. It is improbable that it was Chitrov, who was originally in a subordinate position as a master of fleet, but while serving in Kamchatka and prior to Bering's second voyage was made a lieutenant. It is not likely that a subordinate of Chitrov's position should have been so situated in St. Petersburg as to have served as an interpreter between Bering and de L'Isle. It is therefore more than probable that Lieutenant Sven Waxel was the author of the letter. In further confirmation, this officer says that he is charged with the preparation of a chart out of the material furnished by the maps and journals of the separate vessels. As we know from other sources, Waxel later made a chart of the Kamchatka region. Waxel displayed great energy and excellent judgment in conducting affairs on Bering Island, both before and after Bering's death, and it is gratifying to note his intellectual discrimination in dealing with de L'Isle's fictitious account of a journey in America said to have been made by the Admiral de Font. Waxel skillfully dissects this geographical invention, clearly proving its inconsistencies, while geographical writers in England were engaged years later in endeavoring to prove its truthfulness. It is significant that although Waxel omits any reference to it, the following paragraph, which is evidently intended to be exculpatory of Bering's turning back at the most northerly point of his first voyage, forms part of Bering's report as translated by Dahl. Quote, "Neither from the Chukchi coast nor to the eastward could any extension of the land be observed." Unquote. This very important sentence does not appear in Du Halde's account, and evidently was not in the copy which was furnished him. Possibly the person who furnished the copy to Du Halde omitted it. Elsewhere Waxel adds, quote, "I say nothing here which I have not repeatedly heard Mr. Bering say. I also saw his instructions." Unquote. This gives value to his statements in reference to Bering's efforts to find land east of Availle Bay, whereof Waxel quotes de Lisle as saying, quote, "On his return to Kamchatka in 1729, Mr. Bering learned that there was a land to the east, which could be seen in clear, fine weather. He attempted to go thither, after having repaired the damage his vessel had suffered in a storm. The second attempt was fruitless, for after sailing about 40 leagues to the east without seeing land, he was assailed by a violent tempest and a contrary wind, which quickly drove him back to the port whence he had emerged." Unquote. In criticism, Waxel adds, quote, "Would not this narrative lead one to believe that the second attempt of Mr. Bering had been made immediately after the first voyage, in 1729? However, it was entirely otherwise. Before making this journey, Mr. Bering wintered at Kamchatka, set sail only on June the 5th, 1729, and, without intending to return to the port which he was quitting, doubled the southern point of Kamchatka and went straight to the mouth of the river Bolshaya Reka, and thence to Ochotsk." Unquote. He further says, quote, "Perhaps it may appear strange that Mr. Bering, during this voyage, did not fall in with the island, Bering Island, whereon he was shipwrecked during his second expedition, but the isle might have been hidden by fogs, which are very common in that sea." Unquote. Waxel's account of the second voyage is worth translating, being the plain tale of a participant who is as modest as he is truthful, for Waxel nowhere mentions his own name, nor the efficient service he rendered first to his chief and later to his shipwrecked comrades. He writes in Une Lettre as follows, quote, "Let us now come to the details of the second expedition, which M. de Lisle pretends owes its origin to a map of his, and was undertaken according to a memoir made by himself. I had the honor," he says, "in 1731 to present this chart to the Empress Anne and to the Senate, in order to stimulate the Russians to explorations of what still remained to be discovered, and it had its effect." Was it time or age which caused M. de Lisle to commit this error? Could he have forgotten the orders which led him to make the chart in question? Had he remembered it, perhaps he would not have said that he presented the chart to the Empress, and still less that he made it in order to excite the Russians to new discoveries. At that time I visited M. de Lisle. I was a witness of his geographical labors, as far as they had new discoveries for their object. I acted as interpreter to Mr. Bering in the conversations which he had with him, and I can assert positively that when M. de Lisle began that chart, the second expedition was already ordered, and Captain Bering, knowing what was still wanting to his discoveries, offered to continue them and his lieutenants with him, and they each received promotion in consequence. It is therefore true that M. de Lisle's work must be attributed to the orders of his superiors, and I remember that the Empress Anne, having commissioned her secretary to give the necessary instructions to Mr. Bering for his new voyage, the latter did not think he could carry it on successfully without getting from the Academy all the information possible concerning the countries and waters where he was to navigate. The Academy was therefore called upon by the Senate, and it ordered M. de Lisle to compile the chart of which I speak, and in order that it might be better understood, to explain it in a memoir, which having been done, the chart and the memoir were presented to the Senate by the Academy, so that there can be no possible doubt that, so far from having stimulated the Russians to new discoveries, so far from having occasioned the new voyage of Mr. Bering, M. de Lisle only worked according to the orders he had received. This arises another question as to whether the memoir caused the success of the expedition, which I will treat later on. However that may be, the Senate gave a copy of it to Mr. Bering as well as of the chart. I took a second copy, which enables me to compare it with what M. de Lisle tells us about it in his last memoir from Paris. He pretends to have proposed 3 different routes to be followed in order to discover what was still unknown. The first, to sail straight to Japan, pass Yeco, or rather the straits which separate it from the island of the States and the land of the Company, to discover what is to the north of Yeco, and search for the passage between that country and the coast of eastern Tartary. This is what is called giving advice after the event. In the original memoir there is not a word said about any such researches. M. de Lisle contents himself with proposing 3 different routes for finding the countries lying near to Kamchatka on the east. The first 2, we must admit, agree well enough with the second and third routes mentioned in the Paris memoir. They are expressed in these terms: 1. If one advances to the most northern extremity of Asia, and at the same time the most eastern point reached by Captain Bering (wrong supposition, as I have already remarked), one cannot fail to reach America, no matter what route one takes between the northeast and southeast at a distance of not more than 600 leagues. Great error in estimating the distance of the opposite lands of Asia and America, since they are only separated in the north by a narrow strait which widens as it goes south. 2. Without going so far, it would perhaps be easier to start from the eastern coast of Kamschatka, sail directly east, and reconnoitre the neighboring land, of which Mr. Bering discovered indications on his first voyage. In regard to the third route, M. de L'Isle conjectures as follows. 3. Perhaps the countries seen by Don Juan de Gama might be found more speedily and with more certitude by seeking them to the southeast of Kamschatka, the outcome of which project showed him his mistake, which is apparently the reason that induced him to change it to that of the route of Japan and Yeco. Nothing is so imperfect in detail, and withal so dry, as the recital of Mr. Bering's voyage with which M. de L'Isle regales us. He makes him start in 1741 to look to the east of Kamschatka for the land which he had seen indications of in his first voyage. He did not go very far, he says, for being assailed by a violent storm during thick weather, he could not remain at sea, and brought up on a desert island in latitude 54 degrees, only a short distance from the port of Avachka, from whence he had sailed. Mr. Bering, then, did nothing but fail, and he did so soon after leaving port. I must therefore supplement the meagreness of M. de L'Isle's relation by giving an account of the voyage of Mr. Bering and the other officers, chiefs of these expeditions, which will be so much the more easy as I took part in them, and as I can, besides, refer to the charts and journals of each vessel as proofs of my correctness. The captain commanding Bering and Captains Spangenberg and Chirikov, with several other naval officers, left St. Petersburg in the spring of 1733. They waited at Yakutsk and Ochoksk until the vessels being built at this latter place for their expedition were completed, and when all was ready for the departure of M. de Spangenberg, he was dispatched first according to the orders of the Senate. He started then from Ochoksk in the month of June 1738, having 3 vessels under his command, to which he added a large covered rowboat of 24 oars, which he caused to be constructed at Bolshoretskoy Ostrog, in Kamchatka, where he wintered. This boat was to be used to go into the narrow straits between the islands that they might find and where the ships could not go. In the summer of 1739 he went to Japan, the long chain of islands situated between Japan and Kamchatka serving to guide him. He landed at 2 different places in Japan and was received with great civility by the people of the country. But he never went to Matsmai, the principal place on the island of Yeco, as M. de L'Isle erroneously states. He thought he had sufficiently complied with his instructions without doing so, and returning to Ochoksk, passed the winter at Yakutsk. As soon as a detailed account of this voyage was seen in St. Petersburg, they concluded by the route which Mr. Spangenberg had followed that he must have passed near the coast of Korea, and he was therefore ordered to make a second voyage in order to confirm the first. He started in 1741 and 1742, but his ship, built hastily and of unseasoned wood, leaked and obliged him to return. Messrs. Bering and Chirikov left Ochoksk the 4th of September, 1740. They both had the same destination. The second was to follow the track of the first. They only took different vessels so as to be able to assist each other more efficaciously in case of any accident. Without entering the Rolshaya Reka River, as is customary in coming from Ochoksk, they immediately rounded the southern point of Kamchatka and anchored at Avachka, or port of St. Peter and St. Paul, as they called it. While wintering in these places, they made all their preparations for commencing in spring their principal voyage, which was to have America as its object. Owing, however, to the uncertainty as to the route which they were to follow, Mr. Bering assembled a naval council on the 4th of May, 1741, and it was resolved to endeavor first to discover the land of Don Juan de Gama, a fatal resolution which was the cause of all of our disasters. The 4th June we put to sea. Mr. Bering had on his vessel, sent by the Academy, an adjutant, Mr. Steller, physician by profession, but above all well versed in all that pertained to natural history. M. de la Croyère was with Mr. Chirikov. Although Mr. Bering and Mr. Chirikov were not to separate, according to their instructions, they could not avoid it, for 8 days after sailing they were separated by storms and fogs. The search for the pretended land of Gama caused them to direct their course southeast. They continued to sail in that direction as far as the 46th degree, without, however, finding the slightest vestige of it. Then they changed their course to the northeast, and both reached the coast of America, but in different places and without knowing of the whereabouts of the other. Mr. Bering and we who accompanied him saw land for the first time after being 6 weeks at sea. We then calculated that we were about 500 Dutch leagues from Avacha. We provided ourselves with fresh water. We saw indications of inhabitants, but could perceive no one. After being at anchor 3 days, Mr. Bering consulted with his officers, and it was resolved to return. The 21st July we weighed anchor before sunrise. There was nothing to do but to follow the coast, which stretched westward. But navigation was seriously embarrassed by frequent islands, and when we tried to put to sea we were met by storms and contrary winds, which caused us new delays every day. In order to procure fresh water, we returned towards the coast, from which we had kept as far as possible. Soon it was in sight, seeming about 10 miles distant. We anchored between the islands, and the one where we landed was Shumagin Ostrov. The water was good, but although taken from a lake, there was nevertheless some sea water in it, brought by the tide, which sometimes inundated the island. Afterwards we felt disastrous effects from its use, in sickness and the loss of several of our men, who died. We tried in vain during 3 or 4 days to discover some natives of the country, whose fires we could see at night on the coast. The 4th of September these savages finally came, of themselves, in little canoes, and, having announced their arrival to us by a loud cry, they presented us with their calumets in sign of peace. These calumets were sticks with the wings of falcons attached to the end. We understood from their gestures that they were inviting us to come on land in order to furnish us with provisions and fresh water. We wished to profit by the opportunity, and some of us ventured to follow them. But soon, however, misunderstandings arose, and all communication was broken off. The 6th of September, after having at first had a tolerably good wind for the voyage, we began to find that as we advanced the obstacles were increasing, nothing but coasts and islands on every side. Mr. Bering wished to get away from them by sailing more southwards, and in truth, for several days the sea appeared much more free. Our joy, however, was of short duration. The 24th of September, in latitude 54 degrees, we came upon coasts bordered with a number of islands, and at the same time a violent tempest arose, which lasted 17 days and sent us back a distance of 80 miles. An old pilot acknowledged that during the 50 years that he had followed the sea he had never seen such a storm. We should then stop calling this ocean Pacific. This name may perhaps be suitable to it in the tropics, but certainly is wrongly given to it here. The weather became calm again, but our provisions were by this time considerably diminished, and there was only about a third of our crew who remained well and serviceable after all the hardships to which they had been exposed. There was still more than half of our way to make, counting from the extreme point of our voyage in the east to Avacha. In view of these facts, many of us were of opinion that it would be better to winter somewhere in America rather than run the risk of encountering new dangers, worse perhaps than those we had just escaped. And these counsels came near prevailing over those who were of opinion that we should make a supreme effort to reach Avacha, and that it would be time to think of seeking another refuge when we had lost all hope of succeeding in so doing. The month of October, however, was passed as fruitlessly as the preceding ones. The 30th of that month we came upon 2 islands, which seemed to us to bear some resemblance to the first 2 of those islands which stretch from the southern extremity of Kamchatka to Japan. Thereupon we directed our course northwards, and the 4th November, having observed the latitude, we found that we were under the 56th parallel. The 5th, however, finished our voyage. Wishing to sail to the west, we struck upon a desert island, where we had a good prospect of finishing our lives. Our vessel went to pieces upon one of those banks, with which the island is surrounded, and we were not long in seeking land, which we fortunately reached with everything which we thought we should need. By a special dispensation of Providence, the winds and waves threw the remains of our vessel on shore. We gathered them together to try, with the aid of God, to put ourselves in a position to leave this sorry dwelling. The island, where we now found ourselves, was destitute of trees. We were therefore obliged to depend upon the wood that the sea brought us to build our cabins and warm ourselves. We gave to this desert place the name of Bering Island, in honor of the chief of our expedition, and it was there that he died, on the 8th of December, of grief and sorrow at having to give up all hope of returning to Kamschatka. He refused to eat or drink, and disdained the shelter of our cabins. His advanced age could not rally under such disaster. We young men kept our courage up, resisted with firmness all discouragement, made it a duty to still enjoy life and to make as much as we could out of our prison home. Before our arrival, Bering Island was the refuge only of the inhabitants of the sea, who came there to breathe the air and deposit their young. We were therefore able at first to observe these creatures very closely without their taking fright. It was only after having seen several of their number fall before our guns that they fled at our approach. We killed a great number of them, as much to furnish us with food as for their skins. It was by these valuable spoils, splendid castor skins, that we were repaid in some measure for our sufferings. At the approach of spring the following year we built of the remains of our vessel, as we have intended, a large covered boat, furnished with anchors and sails and able to live at sea if not exposed to storms. In this boat we confided ourselves to the sea, trusting in Providence, the 17th of August, 1742, and after 9 days at sea, with beautiful calm weather, we arrived safely at Availle on the 26th, giving thanks to the Almighty who had delivered us from such great dangers and imbued us with gratitude such as time can never efface. From this account we can correct the error of M. Delisle, who places Bering Island at the 54th degree, only a short distance from Availle, whereas it is on the 56th parallel, 60 miles from Availle and 40 Dutch miles from the mouth of the Kamchatka River. The voyage of Mr. Chirikov, although attended with less fatigue and danger, was not less painful to him. His tender heart, which his profession of mariner had not rendered indifferent to the sufferings of others, was indeed sorely tried. After parting from Mr. Bering, sailing northwest, he came on the 15th of July to a country the shores of which were lined with rugged rocks, on the foot of which rolled a deep sea. He prudently refrained from approaching too near the shore, but at the end of 3 days sent the pilot, Abraham Dementiev, with a crew of 10 men to reconnoitre the country. Neither Dementiev nor any of those who accompanied him ever returned, and most sincerely was he mourned, and deservedly so, for he was young, good-looking, of an honourable family, steady and clever in his profession, and zealous in the service of his country. After waiting 6 days, Mr. Chirikov sent the boatman, Sidor Savalev, with 3 men, but they did not return any more than the others. While waiting for their return, we constantly saw smoke on the shores, and the day after the departure of the boatman, 2 men in different boats came from the spot where Dementiev and Savalev had landed. When they had approached near enough to be heard, they began to call out, "A guy, a guy," and then went back. Mr. Chirikov did not know what to think of their conduct, and now, despairing of the return of his men, and having no more boats to send on shore, he determined on the 27th of July to leave the place, follow the coast as much as possible, and then return to Kamschatka. M. Delisle then makes an addition of his own when he says that Mr. Chirikov made many excursions into the country during the month of August while waiting for the return of his men. To return to the truth, Mr. Chirikov, in a distance of 100 miles, never lost sight of land. He battled often with contrary winds, had much anxiety on account of the heavy fogs, and lost an anchor which he had put out not far from the coast in a moment of great danger. He was visited by 21 canoes of tanned skins, each one containing a man, but this was all, for he was unable to converse with them. The scarcity of water and the scurvy carried off many of his men. Among the officers he lost 2 lieutenants, Lichatchev and Plautin, fine men and excellent mariners, who might have rendered good service had they lived. Mr. Chirikov himself began to have the symptoms of disease, but good food and the air on land restored him to health. M. de la Croyère was not so fortunate. He appeared to have held his own until he was just at the point of death. His companions marveled at the good effects of the large quantities of brandy which he drank every day, but they soon saw that the only good it did him was to make him forget his sufferings. He died on the 10th of October, as they were entering the port of Avacha, having dressed himself to go on shore, and having celebrated his arrival by new excesses. We cannot ignore the important service rendered by M. de la Croyère to the expedition, when he recognized the Americans who came to Mr. Chirikov as bearing great resemblance to the inhabitants of Canada, whom he had met while serving in that country 17 years before coming to Russia with the King of France's troops." Unquote. Note. A pamphlet which has just come into my possession, entitled Lettre de Monsieur d'Anville au R.P. Castel, Je suis, au sujet des pays de Kamchatka, etc., 24, Paris, 1737, throws some light on the map of Du Halt, 1732, and definitely fixes the date and locality of the observation of the eclipse of the moon referred to by de L'Isle and the Russian officer, as well as later geographers. D'Anville says, quote, "The map of Bering's voyage is attributed to me. The only part I had therein was to reduce it from the much larger original map, of which I had made a tracing by means of oiled paper. I first learned of Bering's voyage by letters from de L'Isle, then in Russia, and finally an account of this voyage having been sent to R.P. Du Halt by His Majesty Stanislas, King of Poland, it was placed in my hands. Likewise, both by a sheet of astronomical observations made by Bering, which came to me later, and by the same letters of M. de L'Isle, I knew that the mouth of the river of Kamchatka was found by astronomical determination to be in latitude 56 degrees and some minutes. Bering, in his navigation, doubled the southern point of this continent, Kamchatka, in latitude 51 degrees 10 seconds, as is expressly noted in the sheet of observations which is now before me. But though the solution of the difficulty in the case of the land of Jeco may be very simple and natural, yet it was not obvious to me, it may be said, for Bering's voyage and observations caused me to recur to this subject, and I can no longer doubt that the eastern coast of Tartary should be moved to the east as far as the maps of the Jesuits first indicated. For although M. de Strahlenberg in his excellent map of Siberia shows only 65 degrees of longitude between Tobolsk and Okhotsk, and there are even less in de L'Isle's map of Tartary, yet Bering's map indicates that there are 74 degrees. It was found that it, Okhotsk, is 25 degrees off of the meridian of Peking, which the observations of P. Gaubil placed in 113 degrees 50 odd minutes from Paris, so that it closely approximates the 139 degrees which we have found it to be from Bering's observations. This determination does not differ much from the result of some astronomical observations which, as I learn from China, M. de L'Isle, now in Russia, contemplated using in order to ascertain approximately the longitude of Kamchatka. The observation upon which I place the most dependence, and which likewise gives the greatest difference, is of an eclipse of the moon of February 25th, 1728, of which the end was observed on the west coast of Kamchatka in latitude 52 degrees 46 minutes north, Sirius having an altitude of 19 degrees 18 minutes to the west, wherefrom M. de L'Isle calculated that the true time answered to 6 hours 52 minutes p.m. This eclipse, the end especially, fell throughout Europe in the daytime, but having been observed in Cartagena, West Indies, by D. Jean Herrera, where it ended at 3 hours 34 minutes a.m., a difference of 8 hours 42 minutes is deduced between the meridians of Cartagena and the coast of Kamchatka." Unquote. It is thus evident that Bering observed an eclipse of the moon in Kamchatka, and that the observations came into the hands of M. d'Anville. A.W.G., January the 21st, 1892. End of section 22. Section 23 of National Geographic Magazine, Volume 3. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Height and Position of Mount St. Elias by Israel C. Russell. Laid before the Board of Managers, December 11, 1891. The height and position of Mount St. Elias have been measured several times during the past century with varying results. The measurements made prior to 1891 have been summarized and discussed by W. H. Dull of the U.S. Coast and Geodetic Survey. The various results obtained are shown in the following table. With the exception of the position determined by Malaspina and the measurements of 1891, they are copied from Dull's report. Height and position of Mount St. Elias. Date 1786. Authority La Perouse. Height 12,672 feet. Latitude 60 degrees 15 minutes. Longitude 140 degrees 10 minutes. Date 1791. Authority Malaspina. Height 17,851 feet. Latitude 60 degrees 17 minutes 35 seconds. Longitude 140 degrees 52 minutes 17 seconds. Date 1794. Authority Vancouver. Height left blank. Latitude 60 degrees 22 minutes 30 seconds. Longitude 140 degrees 39 minutes. Date 1847. Authority Russian Hydrographic Chart 1378. Height 17,850 feet. Latitude 60 degrees 21 minutes. Longitude 141 degrees. Date 1847. Authority Tebenkov Notes. Height 16,938 feet. Latitude 60 degrees 22 minutes 36 seconds. Longitude 140 degrees 54 minutes. Date 1849. Tebenkov Chart 7. Height 16,938 feet. Latitude 60 degrees 21 minutes 30 seconds. Longitude 140 degrees 54 minutes. Date 1849. Authority Barkan Inseln. Height 16,758 feet. Latitude 60 degrees 17 minutes 30 seconds. Longitude 140 degrees 51 minutes. Date 1872. English Admiralty Chart 2172. Height 14,970 feet. Latitude 60 degrees 21 minutes. Longitude 141 degrees. Date 1874. Authority U.S. Coast Survey. Height 19,500 plus minus 400 feet. Latitude 60 degrees 20 minutes 45 seconds. Longitude 141 degrees 12 seconds. Date 1891. Authority National Geographic Society Expedition. Height 18,100 plus minus 100 feet. Latitude 60 degrees 17 minutes 51 seconds. Longitude 140 degrees 55 minutes 30 seconds. The position given by Malaspina is from a report on astronomical observations made during his voyage, which places the mountain in longitude 134 degrees 33 minutes and 10 seconds west of Cadiz. Taking the longitude of Cadiz as 6 degrees 19 minutes 7 seconds west of Greenwich, the figures given in the table are obtained. The data from which the various determinations made previous to 1874 were obtained have not been published. The observations made by Messrs. Dull and Baker of the U.S. Coast and Geodetic Survey are published in full in the annual report of the survey for 1875 already referred to. The observations made by myself last summer as a part of the work of an expedition sent to Mount St. Elias by the National Geographic Society and the U.S. Geological Survey, from which the height and position of the mountain have been computed, are as follows. A base line 16,876 feet long was measured on the beach at Icy Bay. The line, with the exception of sections C to D as shown below, was measured 3 times in sections of about 3,000 feet each. The distances given below in columns 1 and 2 were obtained with a 100-foot steel tape, and those given in column 3 with a 300-foot iron wire. These are rough measurements made without the use of a plumb bob and without taking account of temperature. The ground was quite smooth, with a rise of about 5 feet in the center, but section C to D was crossed by a stream channel about 300 feet broad and 20 feet deep. Throughout much of the distance the ground was covered with grass, which was only partially cleared away. The stations at the ends of the line were 10 feet above high tide. The bearing of the line from the western base was south 89 degrees east magnetic. Measurements of base line. Western base to station A, column 1, 3,179 feet 10 inches. Column 2, 3,178 feet 7 inches. Column 3, 3,178 feet 9 inches. Mean 3,179 feet 1 inch. Station A to station B, column 1, 2,355 feet 2 inches. Column 2, 2,354 feet 1 inch. Column 3, 2,354 feet 2 inches. Mean 2,354 feet 6 inches. Station B to station C, column 1, 3,589 feet. Column 2, 3,587 feet 9 inches. Column 3, 3,586 feet. Mean 3,587 feet 7 inches. Station C to station D, column 1 rejected. Column 2, 2,609 feet 2 inches. Column 3, 2,609 feet 5 inches. Mean 2,609 feet 3 inches. Station D to eastern base, column 1, 5,145 feet 5 inches. Column 2, 5,144 feet 10 inches. Column 3 not measured. Mean 5,145 feet 1 inch. Length of base line, mean 16,875 feet 6 inches. The measurements of angles were made with a gradient reading by Vernier to minutes. The error of the vertical arc was -3 minutes and remained constant during the observations. Instrumental observations. Measurements of angles at western base. 1. St. Elias to eastern base. Right vernier 218 degrees 35 minutes to 317 degrees 6 minutes. Left vernier 38 degrees 35 minutes to 137 degrees 7 minutes. Vertical angle +5 degrees 40 minutes. Date 1891, August 14th, 10 a.m. 2. St. Elias to eastern base. Right vernier 218 degrees 34 minutes to 317 degrees 6 minutes. Left vernier 38 degrees 37 minutes to 137 degrees 7 minutes. Vertical angle +5 degrees 40 minutes. Date same as last. 3. St. Elias to eastern base. Right vernier 218 degrees 37 minutes to 317 degrees 6 minutes. Left vernier 38 degrees 39 minutes to 137 degrees 8 minutes. Vertical angle +5 degrees 40 minutes. Date same as last. 4. St. Elias to eastern base. Right vernier 261 degrees 41 minutes to 0 degrees 10 minutes. Left vernier 81 degrees 43 minutes to 180 degrees 11 minutes. Vertical angle plus 5 degrees 40 minutes. Date same as last. 5. St. Elias to eastern base. Right vernier 261 degrees 41 minutes to 0 degrees 10 minutes. Left vernier 81 degrees 43 minutes to 180 degrees 10 minutes. Vertical angle plus 5 degrees 40 minutes. Date same as last. 6. St. Elias to eastern base. Right vernier 50 degrees 15 minutes to 148 degrees 45 minutes. Left vernier 230 degrees 15 minutes to 328 degrees 45 minutes. Vertical angle plus 5 degrees 40 minutes. Date 1891, August 14th, 6 p.m. 7. St. Elias to eastern base. Right vernier 50 degrees 15 minutes to 148 degrees 45 minutes. Left vernier blank. Vertical angle blank. Date same as last. 8. St. Elias to eastern base. Right vernier 181 degrees 5 minutes to 279 degrees 30 minutes. Left vernier 1 degree 5 minutes to 99 degrees 32 minutes. Vertical angle plus 5 degrees 40 minutes. Date same as last. Measurements of angles at eastern base. 1. St. Elias to western base. Right vernier 252 degrees 26 minutes to 176 degrees 19 minutes. Left vernier 72 degrees 27 minutes to 356 degrees 19 minutes. Vertical angle plus 5 degrees 34 minutes. Date 1891, August 17th, 11:30 a.m. 2. St. Elias western base. Right vernier 252 degrees 26 minutes to 176 degrees 19 minutes. Left vernier 72 degrees 26 minutes to 356 degrees 19 minutes. Vertical angle plus 5 degrees 34 minutes. Date same as last. 3. St. Elias to western base. Right vernier 252 degrees 25 minutes to 176 degrees 19 minutes. Left vernier 72 degrees 26 minutes to 356 degrees 19 minutes. Vertical angle plus 5 degrees 34 minutes. Date same as last. 4. St. Elias to western base. Right vernier 252 degrees 26 minutes to 176 degrees 19 minutes. Left vernier 72 degrees 27 minutes to 356 degrees 19 minutes. Vertical angle plus 5 degrees 34 minutes. Date same as last. 5. St. Elias to western base. Right vernier 252 degrees 26 minutes to 176 degrees 19 minutes. Left vernier 72 degrees 26 minutes to blank. Vertical angle plus 5 degrees 34 minutes. Date same as last. 6. St. Elias to western base. Right vernier 252 degrees 27 minutes to 176 degrees 20 minutes. Left vernier 72 degrees 28 minutes to 356 degrees 20 minutes. Vertical angle plus 5 degrees 34 minutes. Date 1891, August 17th, 2 p.m. 7. St. Elias to western base. Right vernier 252 degrees 28 minutes to 176 degrees 21 minutes. Left vernier blank. Vertical angle blank. Date 1891, August 17th, 4:30 p.m. From these observations, the following angles between the base line and the line of sight to the summit of Mount St. Elias are obtained. The correction for error of vertical circle has been applied to the angles of elevation. Resulting angles. Western base 1. Right vernier 98 degrees 31 minutes. Left vernier 98 degrees 32 minutes. Corrected vertical angle plus 5 degrees 43 minutes. 2. Right vernier 98 degrees 32 minutes. left vernier 98 degrees 30 minutes, corrected vertical angle plus 5 degrees 43 minutes. 3. Right vernier 98 degrees 29 minutes, left vernier 28 degrees 29 minutes, corrected vertical angle plus 5 degrees 43 minutes. 4. Right vernier 98 degrees 29 minutes, left vernier 98 degrees 28 minutes, corrected vertical angle plus 5 degrees 43 minutes. 5. Right vernier 98 degrees 29 minutes, left vernier 98 degrees 27 minutes, corrected vertical angle plus 5 degrees 43 minutes. 6. Right vernier 98 degrees 30 minutes, left vernier 98 degrees 30 minutes, corrected vertical angle plus 5 degrees 43 minutes. 7. Right vernier 98 degrees 30 minutes, left vernier blank, corrected vertical angle plus 5 degrees 43 minutes. 8. Right vernier 98 degrees 25 minutes, left vernier 98 degrees 27 minutes, corrected vertical angle plus 5 degrees 43 minutes. Mean for right vernier 98 degrees 29 minutes 22 seconds. Mean for left vernier 98 degrees 29 minutes 0 seconds. Total mean 98 degrees 29 minutes 12 seconds. Corrected vertical angle plus 5 degrees 43 minutes. Eastern base 1. Right vernier 76 degrees 7 minutes, left vernier 76 degrees 8 minutes, corrected vertical angle plus 5 degrees 37 minutes. 2. Right vernier 76 degrees 7 minutes, left vernier 76 degrees 7 minutes, corrected vertical angle plus 5 degrees 37 minutes. 3. Right vernier 76 degrees 6 minutes, left vernier 76 degrees 7 minutes, corrected vertical angle plus 5 degrees 37 minutes. 4. Right vernier 76 degrees 7 minutes, left vernier 76 degrees 8 minutes, corrected vertical angle plus 5 degrees 37 minutes. 5. Right vernier 76 degrees 7 minutes, left vernier blank, corrected vertical angle plus 5 degrees 37 minutes. 6. Right vernier 76 degrees 7 minutes, left vernier 76 degrees 8 minutes, corrected vertical angle plus 5 degrees 37 minutes. 7. Right vernier 76 degrees 7 minutes, left vernier blank, corrected vertical angle blank. Mean for right vernier 76 degrees 6 minutes 51 seconds. Mean for left vernier 76 degrees 7 minutes 36 seconds. Total mean 76 degrees 7 minutes 10 seconds. Corrected vertical angle plus 5 degrees 37 minutes. The known elements of the triangle from which the distance of St. Elias from the ends of the base line may be determined are: angle at western base 98 degrees 29 minutes 12 seconds, angle at eastern base 76 degrees 7 minutes 10 seconds, distance between western base and eastern base 16,876 feet. These data were sent from the field to the Secretary of the National Geographic Society and, in connection with other measurements made at the same time, have been computed by Mr. S.S. Gannett of the United States Geological Survey. The results of the computation, so far as they relate to Mount St. Elias, are given below. Computation of the height of Mount St. Elias. Logarithm distance eastern base to western base 16,876 feet equals 4.227270. Station St. Elias, angle 5 degrees 23 minutes 38 seconds. AC logarithm sine equals 1.026862. Station Western Base, angle 98 degrees 29 minutes 12 seconds. Logarithm sine equals 9.995218. Station Eastern Base, angle 76 degrees 7 minutes 10 seconds. Logarithm sine equals 9.987129. logarithm distance St. Elias to western base equals 5.241261. Logarithm distance St. Elias to eastern base equals 5.249350. Next, logarithm distance St. Elias to western base equals 5.241261 logarithm feet, or 1.518627 logarithm miles, or 33.01 miles. And a logarithm tangent angle of elevation 5 degrees 43 minutes equals 9.000465, which gives us 4.241726, which is the logarithm 17,447 feet. Correction for curvature and refraction in feet equals 4/7 squared of distance in miles. Logarithm distance miles equals 1.51863. Logarithm 4 equals 0.60206. AC logarithm 7 equals 9.15490, giving us 2.79422, which is logarithm 623 feet. So 17,447 feet plus curvature and refraction 623 plus western base above sea 10 equals St. Elias above sea 18,080 feet. Next, logarithm distance St. Elias to east base 5.249350 logarithm feet, or 1.526716 logarithm miles, or 33.63 miles. Logarithm tangent angle of elevation 5 degrees 37 minutes, 8.992750 longitude feet, giving us 4.242100, which is 17,462 feet. Correction for curvature and refraction in feet. Logarithm distant miles 1.526716, logarithm 4 0.602060, AC logarithm 7 9.154902, which gives us 2.810394, which is logarithm 646 feet. So 17,462 feet plus curvature and refraction 646 feet plus eastern base above sea 10 equals St. Elias above sea 18,118 feet. Mean elevation above sea level equals 18,099 feet, or in round numbers 18,100 feet. Mr. A. Lyndon Cole of the U.S. Coast and Geodetic Survey and Mr. S.S. Gannett have each computed the geographic position of Mount St. Elias using the azimuth and angle of elevation of the mountain obtained by the U.S. Coast Survey at Port Mulgrave in 1874 and the elevation given above. From these data, the approximate position of Mount St. Elias was found to be latitude 60 degrees 17 minutes 51 seconds north, longitude 140 degrees 55 minutes 30 seconds west. The computation by which these results were obtained is given below. Computation of geographic position of Mount St. Elias. Azimuth, Port Mulgrave to Mount St. Elias, equals 152 degrees 17 minutes 17 seconds. Difference azimuth, minus 59 minutes 55 seconds, plus 180 degrees, equals azimuth Mount St. Elias to Port Mulgrave, 321 degrees 17 minutes 22 seconds. Port Mulgrave latitude, 59 degrees 33 minutes 42 seconds, difference latitude plus 44 minutes 9 seconds, equals Mount St. Elias latitude, 60 degrees 17 minutes 51 seconds. Port Mulgrave longitude 139 degrees 46 minutes 16 seconds. Difference in longitude plus 1 degree 9 minutes 14 seconds equals Mount St. Elias longitude 140 degrees 55 minutes 30 seconds. Next, first term, logarithm k, that is distance Mulgrave to St. Elias, equals 5.0183184 in logarithm meters. Logarithm cosine azimuth z 142 degrees 17 minutes 17 seconds equals 9.8982292 in logarithm meters. Logarithm b equals 8.50939002, which gives us 3.425938, which is the logarithm 2666.5 seconds. Second term, k squared equals 0.0366, sine squared z equals 9.5731, logarithm c equals 1.6335, which gives us 1.2432, which is the logarithm 17.6 seconds. Thus, first term plus 2666.5 seconds, second term minus 17.6 seconds equals the difference in latitude 2648.9 seconds. Next, logarithm k equals 5.0183184, logarithm sine azimuth equals 9.786538, logarithm a equals 8.508648, arithmetical complement 60 degrees 17 minutes 51 seconds equals 0.30499593, giving us 3.618423, which is the logarithm difference in longitude 4153.6 seconds. Thus, logarithm difference in longitude equals 3.61843, logarithm sine mean latitude 59 degrees 55 minutes 46 seconds equals 9.93722, giving us 3.55565, which is the logarithm difference azimuth minus 3595 seconds. Note, A, B, and C are terms depending on the size and figure of the Earth and the latitude of the place. The geographic position of Mount St. Elias is of popular interest in connection with the boundaries of Alaska. In the convention between Great Britain and Russia, wherein the boundaries of Alaska are supposed to be defined, it is stated that the boundary beginning at the south after leaving Portland Channel shall follow the summit of the mountain situated parallel to the coast as far as the 141st meridian, and from there northward the said meridian shall be the boundary to the Arctic Ocean. Whenever the summit of the mountains between Portland Channel and the 141st meridian shall prove to be at the distance of more than 10 marine leagues from the ocean, the limit between the British possessions and the line of coast which is to belong to Russia, above mentioned, shall be formed by a line parallel to the windings of the coast, and which shall never exceed the distance of 10 marine leagues therefrom. Unquote. As Mount St. Elias is approximately in longitude 140 degrees 55 minutes 30 seconds west from Greenwich, as already shown, it is therefore only 4 minutes and 30 seconds of longitude, or 2½ statute miles east of the boundary of the main portion of Alaska. Its distance from the nearest point on the coast is 33 statute miles. There is no coast range in southeastern Alaska parallel with the coast within the limits specified by the treaty, and the boundary must therefore be considered as a line parallel with the coast and 10 marine leagues, or 34½ statute miles inland. The mountain is thus 1½ miles south of the boundary and within the territory of the United States. Its position is so near the junction of the boundary separating southeastern Alaska from the Northwest Territory with the 141st meridian that it is practically a corner monument of our national domain. End of section 23.
Section 24 of National Geographic Magazine, Volume 3. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by MaryAnn Spiegel. The Heart of Africa by E. C. Hoare. 1. The subject of Africa and its people has recently become a most interesting and popular one. We are but now beginning to realize the size and importance of Africa, as we are reminded that it contains nearly 1/4 part of the land area of the world, that it has mountains at least 1,000 feet higher than the most lofty American peaks, that the known extent of the Nile and the Congo now make them the rivals of the Yangtze Kiang and the Mississippi as the longest rivers in the world, that its central regions, instead of the great desert blank so long shown on our map, is a rich and beautiful elevated region, having upon its heights a splendid collection of freshwater lakes or inland seas, fertilizing by their outflowing streams the whole continent, and that it is known to contain over 250 million people, or about 1/7 part of the world's population. It is called the Dark Continent. Rather should it be called the New World, in which our interests and responsibility, political, commercial, and social, is rapidly growing. For purposes of general description, there are 3 great divisions of the African continent and its peoples and affairs. The northern division, stamped and characterized, men, manners, and things, by the Orientalism of its conquering settlers, so intimately blended by blood, religion, and character with the natives as to have become essentially African, its original peoples so thoroughly influenced by the incoming foreigners as to be now essentially Oriental. The southern division, overrun in more modern times by foreigners of other races, and having its own peculiar civilization and characteristics due to that influx, and Central Africa, including all that portion of the continent lying between, say, the Albert Nyanza and the river Zambesi, and Zanzibar and the Congo mouth, and which, although no part now remains of it that is not nominally the territory either of the Congo Free State or some European power, is still almost entirely in the possession and occupation of its lawful owners, the native uncivilized tribes. As well as this transverse political division of Africa, we may make what may be called a concentric analysis. Commencing with the outer skin, the 16,000 miles of African coast, we find upon it certain excrescences, which, if our examination went but skin deep, might well lead us to regard Africa not as a new, but as an old, old world. On the north and east, the remains of ancient civilizations, Morocco, Tangier, Egypt, remind us of Africa's bygone grandeur, remind us how very much of forms of beauty and secrets of science and art came to us in the birth of civilized Europe from or through Africa. On the south and west again, memorials of Phoenician, of Portuguese, of Dutch, English, and American conquering visitors and adventurers remind us of the constant preying of the nations on the dark continent, remind us, through certain prison castles still to be seen on the western coast, of the great world's crime, the slave trade. But on the outer surface of Africa other signs are to be read. North, south, east, and west there are ports and roadsteads forested with the mass of the world's shipping conveying to Africa's every shore those products of the civilized world which, according to their nature, for good or harm, are to influence and civilize the Africans. Carrying away from her shore the land's products, a constant stream, increasing perhaps just now, but which has always been flowing, of wool, cotton, oil, rich spices, dyes, and medicinal and ornamental woods, India rubber, gum copal, ivory, precious stones, gold. Are these the products of a desert land inhabited only by a lazy and savage people? Following our concentric analysis, the first layer behind the outer skin of Africa may be said to consist of a verdant slope, broad and luxuriant in the tropics, where nature herself has been lavish, narrower but still ever widening in the drier north and south, as the Oriental and the European respectively advance their groves of fruit and fields of corn, maintained in luxuriance alike by the vapors of the sea and the down drainage from the higher lands, and from the same causes also malarious and unhealthy. In another sense, too, this outer belt is both rich and unhappy. Into it come those men and things representing civilization from afar. To it, from the interior, gravitate those of the natives who are influenced by contact with those men and things, deprived to a great extent of the old uncivilized condition and its innocencies, and partly imbued with what of civilization has come to them. Mankind, too, in this outer belt is often only too rank and unhealthy in his character. It is truly darkest Africa. For, first, the slave trade, and then the rum bottle, have in many parts been the preponderating representatives to them of outer civilization. The next layer is a steppe or terrace of flat, sandy, semi-arid country, narrow in the tropics, widening toward each extreme, until it bulges out in the north into the Sahara Desert, in the south into the Kalahari, some parts always bare and sandy, or covered with a sparkling saline or alkaline deposit, some parts forming broad savannas or prairies, bearing rich grasses in the rains, burnt bare in the dry season. Others covered with thickets of thorns or stunted and crippled trees under the same variations of seasons. This is the land of the ostrich and the pelican, the scene of vast prairie fires or whirling dust sprouts. It is the land also of the nomad man. Across the Sahara the wandering Arab leads his camels from oasis to oasis. Amid the wastes of the Kalahari, the homeless bushman finds a congenial hunting territory. In the narrow, tropical parts, such semi-nomads as the Somali, the Wamasai, and the Wagogo lead their cattle from place to place, as the grass and water serve them with the seasons. This terrace or flat sandy belt being crossed, we come to the true central region of Africa, a long, irregular, oval-shaped elevation of mountain masses, spreading out in many places as vast plateaus, and forming altogether that mysterious elevated region reported from time to time by old investigators as well as compilers of native reports as the Mountains of the Moon. In the crevices of this central mass, in rocky basins, in fathomless chasms, in vast depressions of the plateaus, lie those great natural rainwater tanks known as the Central African Lakes. On and around it are the richest and most beautiful and healthful countries. Spreading over it and around its beautiful waters are the most intelligent and industrious of the native African tribes, their native industry and enterprise yet almost undisturbed by the busy excitement of civilization. Hence there may fairly be drawn something like a sample of the real African native character and condition. They live in families. Among them the family tie and the rights of property are regarded. Conscience pronounces criminal and offensive the same irregularities as are so regarded among civilized people. In stature and physical condition they come up to the best standards. I argue that the life and condition which presents this state of things after isolation for thousands of years from all we call civilized can scarcely be called evil or degraded. Among these people, both pastoral and agricultural, are to be found in progress the germs at least of all the useful arts, the procuring and working of both iron and copper, pottery making, the spinning and weaving of cotton cloth, the very beautiful development of plaiting of all kinds of vegetal fibers into string, rope, mats, baskets, and cloth, and where valuable materials and products are naturally confined to particular localities, as is the case sometimes with oil, salt, etc., it is manufactured and distributed. Too often are people described as lacking in industry, who are not the same as ourselves, but it seems to me ridiculous that a man should be called lazy because he has ample leisure between his busy times, who has made with his own hands, from nature's absolutely raw materials, his house, his axe and hoe and spear, his clothing and ornaments, his furniture, his corn mill, all things that he has, and who, though liable often in a lifetime to have to repeat that whole process over again, has the energy and enterprise to commence afresh. Too often have the same people been called savage and bloodthirsty who, through all experience and by all their traditions getting naturally to regard unintroduced armed strangers as enemies, have the same desperate energy to defend themselves and their own which, as displayed by our own ancestral relatives, we love to term patriotism and courage. In a fairly central position on this great central elevation is the elongated basin surrounded by a mountain rim in the bottom of which, in a long chasm, lies Lake Tanganyika, in a position alike so central and so unique that I have termed it the heart of Africa. Inside the mountain basin rim, the rainfall all converges into Tanganyika. Outside, it all flows to the outer shores of the continent by the Nile, the Congo, or the Zambesi. 15 years ago the waters of Lake Tanganyika, having very slowly gained upon the evaporation, then the only means of carrying off its surplus, attained to the height of the lowest gap in its rim and commenced to flow out. And thence its surplus water ever since has found an exit and now forms part of the Congo system. Tanganyika is 400 miles long and from 15 to 50 miles in width, and is 2,700 feet above the sea. To leave, however, this very rough general description of Africa at this point would convey a wrong idea. We have described the verdant slope from the coast, the terrace of flatter country, the central elevation and its heart. Now we may imagine a series of great ridges and furrows and other radial features diverging from the heart of Africa to its very shores, besides certain isolated ridges and peaks, some of them snow-clad, and certain isolated depressions forming lakes or swamps. First the 3 great furrows of the Nile, Zambesi, and Congo, and 3 great ridges formed by their dividing watersheds, and so on through fan-like expansions of rim or ridges and furrows until the previously described concentric formation, although still there, is considerably cut up. The great central mountain mass, buttressed by its far-stretching ridges, forms the backbone from which, outward and downward, in intricate articulations, extends the complicated bony skeleton of Africa. Set like sparkling jewels in its crevices and depressions, the Great Lakes send forth the streams which, flowing through gaps in their surrounding mountain barriers, rushing through narrow channels, oozing slowly through elevated flats, or bounding in beautiful cascades over steep steps, and carrying the vitalizing fluid in every direction through the length and breadth of Africa, form its system of circulation. Bordering the Great Lakes and clustering upon the slopes, forests of gigantic trees form the flesh and muscle of this great creation. Preserved in perpetual verdure, wherever water constantly remains, and in long extending lines and network fringing the ever-winding banks of the streams, and finally joining with the verdant belt of the sea-coast to form the brilliant epidermis of the whole, and forming background and filling to the network of those prominent features, in broad concentric curves and in belts and patches, the more stunted thorny growth, long grass, broad savanna, and sandy plain, ever changing in color and aspect. The great, new, and beautiful world of Africa lies open before us. 250 million intelligent and courageous people have become exposed to the influence, for good or evil, of the civilized races. What shall we do with it, and them? Quite possible is it, fairly and honestly so, to explore and deal with both country and people, as to develop its resources and benefit them, while adding to the world's treasury of comfort-bringing products and human brotherhood the riches and the friendship of a new continent. But it must be by peaceful and just measures, and by honest trade with wholesome wares. 2. As a practical way of leading you in imagination to the heart of Africa, and as indicating the circumstances and experience upon which my observations of Africa are based, I shall describe one of my many journeys. In the year 1882, I had the honor to be the leader of the largest European expedition that has yet entered Africa, having in it, for instance, 200 more men than the Emin Pasha relief expedition. There were 10 Europeans, all told, who represented survey and navigation, medicine, carpentry, blacksmithing, and other specially selected talent for the purpose of exploration and civilization, as well as those specially devoted to the teaching of Christianity, which was the ultimate aim of all. We entered Africa from the village of Saadani on the eastern coast, opposite Zanzibar, our destination being the shores of Lake Tanganyika at Ujiji. To make not only our progress sure, but work and residence at our destination safe and possible in such a land, we had stores of groceries, medicines, tools, clothing, and a large quantity of calico and other cloth, which forms the currency of the country for the purchase of supplies and payment of wages to porters, servants, and workmen. The special locality to be worked being the country surrounding Lake Tanganyika, to which that extensive and beautiful inland sea gives access, we carried with us also, for its navigation, a sailing boat built of steel, of the form of a sea-going lifeboat, and constructed in small sections and pieces for transport. This boat I designed myself. 6 of the sections were travelled on specially constructed light carts, drawn by African natives, and the rest, in small pieces, were to be carried by the porters in the ordinary way. The mode of travel was walking, except when now and then an invalid was carried in a hammock. The method of transport was by means of native porters, hundreds of whom devote themselves to this work. They are paid $5 per month as wages, payable at Zanzibar on their return to the coast, less such advance in kind as they may draw from their leader along the road. In addition, they get a regular allowance of 2 yards of white calico per 7 days, each man, as barter with which to obtain food. The organization and start of such a party took some time, and parties from 100 to 300 were dispatched along the road as things were ready, until, when I started with the final rear guard, we had on the road over 900 of these porters, with their headmen and petty officers, all under complete organization. At first start of the boat section carts was the scene of apparent disaster. The men, wild with excitement and uniting their shouts with those of onlookers, were beyond all restraint for the moment, and as they rounded a sharp turn to get out of the village of Saandani, over went the carts, one after the other, on their sides, and it was some time before I could train the men to steer more carefully or to move more gently down a declivity. In time, however, the whole thing worked well. The fore-compartment of the boat, going stem first, often forced its own way through masses of brush and creeper, helping to clear the way for the narrower sections, whose carts insinuated themselves through surprisingly small gaps. The men themselves were most zealous in the service, and as we emerged from lengthy stretches of jungle, ascended steep river banks, or jolted whole days over rugged stony places unharmed, we made up our minds that these carts would go anywhere. In 20 days, we reached Apwapa, 200 miles from the coast, and joined an advance party awaiting us, and after a few days' rest and reorganization, we started once more westward. The first village beyond, in the country of Ugogo, was 30 miles off. The first day was a comparatively easy march to a watering place, but the next 2 days gave us tough work. The thick, tangled, thorny scrub became quite dense, and for those 2 days we had to cut our way through it foot by foot. Hour after hour the twang of the sword bayonets and the thud of the axes were almost the only sounds to be heard till the train of carts moved slowly on as the way was opened. Toward evening of the second day we followed a narrow pass along the side of a rocky river bed, stout, inflexible trunks and branches here projecting into our path. On some of these ebony bars the axes resounded as on an anvil, and they yielded only to the more patient saw. As the sun descended we began to flag, but help was at hand, for a party coming back to us from the camp ahead with food and water, we picked up strength and spirit and reached camp late in the evening. The level plains of Ugogo, which here represent the flat, open steppe or terrace to which I have referred in the general description of Africa, enabled us to make a week or so of splendid and comfortable marches. Ugogo passed, there lay before us the much-dreaded wilderness, so called, of the Magunda Magali, separated from Ugogo by a steep, rocky ascent which we could only tackle one cart at a time, and we soon came to a point so rugged with broken rocks that we could proceed no farther, but the sections were unlashed, the carts taken to pieces, and all handed or dragged across the difficult place and put together again beyond. Over the scrubby, rugged hill and dale of Muganda Mkali, without inhabitants, 15 to 25 miles a day was often made. Every man knew the necessity of pushing on for food and water, and the danger, from wild beasts or wandering highwaymen, of lagging in the rear. On went the novel train, through weary miles of forest, across the scorched plain, rattling over the hard, sun-baked footprints of the elephant and rhinoceros, on through grassy glades where the nimble antelope bounded, scared out of our path, and the zebra and giraffe were startled by the rattling of these strange disturbers of their solitude. On still through miles of swamp, with its croaking legions, on through scenes of surpassing beauty, bright flowers and gleaming birds and butterflies, on past the bleaching bones of other travelers waylaid or exhausted, till the sun creeps up high overhead and eager glances are cast at green spots where water once had been. On, till the pace grows slow with weariness and thirst, and still on, till it revives again as the welcome messenger from the front appears in sight with water, or the campfires tell of food and rest. Completing this difficult section of the journey, and mounting to the beautiful forests and numerous villages of Unyamwezi, we had arrived upon the central heights of the continent, which everything around us bespoke its best part. The clearer, more healthy air, the rich land, the open forests, the numerous and industrious people, all spoke eloquently of a better and brighter state of things in the interior of Africa than on its outside. At Urambo we elicited the pleased surprise of our friend, the famous chief Mirambo. Said Mirambo, laying his hands emphatically on one of the boat sections, "This boat and these carts are mine, and all Unyamwezi is yours." It was his way of expressing sympathy and admiration of what he considered to be a very wonderful enterprise, and we left him pondering more deeply than ever on the doings of the white men. The rains were now at hand, and the country rich and verdant. We hastened on with all speed possible, to enable us to cross the Malagarassi River before it should be too swollen. Emerging from elevated forest land to a view of the valley of the river, it appears like a vast level expanse of harmless grass, but the swift river is flowing in the bottom. The toll required by the natives being paid, we descended to the river through the thick grass. We crossed the river in tiny dugout or bark canoes managed by the natives. One old man, a leader among these ferrymen, we had especial cause to notice. We called him the Old Admiral. He wore a curious skull cap apparently made of bladder, and presented a most odd appearance. To him we paid a special fee of propitiation for the boatmen. As we proceeded down toward the river, the first sign of it among the long grass was quiet shallow water in the path. This grew deeper and deeper as we walked on, until we were immersed to the armpits, the grass rising avenue-like overhead. We emerged on a small island or rising ground, and the river proper was before us. On this little eminence stood the old admiral, superintending all. The porters and their ordinary loads all crossed in the usual way, 2 or 3 at a time in the little canoes. The 2 large carts, with the bow and stern compartments of the boats, were floated along the watery avenue by the buoyancy of their tank-like loads. The others came, sections and carts, separately. The fare for each load was 1 yard of calico, but when the carts appeared there was general astonishment among the ferrymen, who showed signs of clearing off altogether. The old admiral alone was unmoved. His stolid countenance showed no sign but a deep bass growl. 8 yards for these, expressed at once his nonchalance and his determination. And 8 yards we had to pay. All was safely got over in a day. 2 of the bark canoes were lashed together with poles across, and 1 section or 1 cart at a time was laid on top, and thus all was carried across. Obstacles which further back would have been regarded as great hindrances were now made little of. Success seemed assured to all, and even the men began to rehearse their triumphal entry into Ujiji. 1 more difficult river, the Lusugi, we had to cross. We reached its banks down a rocky descent late one night in a heavy fall of rain. We waited an hour or 2 next morning till the river had somewhat subsided, and then commenced work. 2 or 3 volunteers swam across with a stout rope, which was then hauled tight across the stream. The porters, holding this rope in one hand, slowly but surely made their way across. Then the carts and sections were attached to a block running on the rope, and so, carefully attended by 2 or 3 men, were floated over to safety. Ujiji was now only a few marches ahead. The view of the lake was caught at last, a narrow strip of its waters gleaming in the sun in the distance, and next morning we slowly marched into Ujiji in a compact body. The boat was duly launched and has now been for years at work on Lake Tanganyika in the cause of civilization and Christianity. The completion of this journey, however, was but the commencement of a still larger enterprise in the region reached. Stations were established among the tribes on the lake shores. A larger vessel, with steam power, was built and launched on the lake, and a substantial mission was established, and is still at work, at a point which is only 400 miles from that point on the Congo River accessible to the steamers of the missions there. All this work I have described was done at the expense of the London Missionary Society. End of section 24.
Section 25 of National Geographic Magazine, Volume 3. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Report of Committee on Exploration in Alaska. Accepted April 3, 1891. Washington, D.C., April 3, 1891. To the Board of Managers of the National Geographic Society, Washington, D.C. Gentlemen, your committee, instructed to consider the advisability of further Alaskan exploration by the Society this year, and if deemed advisable, to consider and report upon ways and means for accomplishing it, respectfully submit the following report. The general question of desirability has been decided affirmatively by the Board of Managers. It therefore is inferred that the question of advisability may be taken as involved in that of ways and means. In outlining a plan of work concerning which such inquiry is to be made, it has been found necessary, in the lack of formulated opinion by the Society, to make assumptions as to what should be its purpose and policy in undertaking exploration. It is assumed tentatively that in order best to further the object for which the Society is organized, namely, the increase and diffusion of geographic knowledge, the aim in exploration should be not so much to promote the growth of science as to diffuse a general interest in geographic work in its several departments, and, adhering to the principle of attractiveness, to increase the sum of knowledge by discovery and by the addition of general and elementary facts rather than by detailed investigation, for appreciation of which scientific training must be presupposed. It is furthermore believed that the policy of the Society should be to invite cooperation, offering opportunity at the same time for special study in related sciences, to effect the organization and devise the plan, and itself to take part directly in field work only so far as may be necessary to initiate and promote it. Your committee find that apparently it will be practicable, with cooperation, for the Society to extend this year the exploration work of last year in the vicinity of Mount St. Elias. Specifically, it is recommended that the plan be to determine directly from a long baseline near the coast the height of the mountain, to ascend it, to observe systematically the unique phenomena of physical geography of the Malaspina Glacier from Icy Bay to the initial point of last year's exploration, and to explore the Seward Glacier to its head if deemed advisable after the ascent of the peak. In view of the fact that it is the purpose of the Coast and Geodetic Survey to carry the International Boundary Survey into this region within 1 or 2 years, it is considered inexpedient for the Society to undertake extended topographic work. It is, however, submitted, as a principle which this Society should emphasize in projecting exploration, that facts of physical geography have minimum value and may lead to false conclusions unless correlated through their space relations, and it is recommended that the expedition aim always to employ such means as may be practicable for making record of its course and of its observations in approximate geometric relation to surroundings. Conditional offers of cooperation have been made by the Revenue Marine Service, the Geological Survey, the Coast and Geodetic Survey, and the Century Company of New York. Transportation from Seattle to Alaska and return, it is thought, may be secured on the steamer Corwin, and that vessel's commander, Captain Hooper, has expressed a desire to extend his coastline exploration of last year by making a survey of Disenchantment Bay. The Geological Survey offers to detail Mr. Russell to conduct the expedition, and to bear the expense of a number of field hands and of their equipment. The Coast and Geodetic Survey has expressed a desire to aid, if practicable, by beginning boundary work in the same field this year, and incidentally to do other surveying with special relation to the work of the expedition. The Century Company offers to send an artist experienced in alpine work and to pay the greater portion of his expenses. The opportunity for study of the fauna and flora of the region, it is thought, should not be neglected. The cost to the Society, wholly in items of field expense otherwise unprovided for, which may be considered as the cost of enabling the combination to work as one organization, is estimated at $500. The expedition should leave Seattle in the latter part of May, aiming to reach Icy Bay by the 1st of June, and field work should close by the end of September. Your committee consider further exploration in Alaska by the Society this year as practicable, and recommend that the proposed expedition be authorized and that Mr. Russell be at once invited to organize and conduct it, under the auspices of the Society. Very respectfully, G. K. Gilbert, Everett Hayden, Willard D. Johnson, Committee on Exploration. End of section 25.
Section 26 of National Geographic Magazine, Volume 3. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Sam Reisman. Notes. La Carte de France, dite du l'état major par Monsieur Jean Collet, Paris, 1887. Octavo, pages 92 with 4 plates. This pamphlet describes the great staff map of France, recently completed, giving its history, the methods employed in the field and office work, the contents of the map, and the means of representing the various features therein described. The scale of the map is 1 to 80,000. Relief is represented by hachures, for drawing which approximate contour lines have been located, but these are not otherwise used. A great variety of cultural features are shown, many of which are ephemeral, and which contribute to the overloading of the map with details. Moreover, as the time which has ordinarily elapsed between the survey and the issuance of the work in printed form is 10 or 12 years, most of this culture has become not only of no value, but misleading by the time it is published. The account of the organization and methods by which the map has been produced is of special interest. The primary triangulation upon which it is based is one of the most elaborate and accurate ever executed in any country. No expense has been spared in this direction. Within this triangulation is a secondary triangulation, also very elaborate, from the stations of which numerous additional points are cut in, or located by unclosed triangles. All this work is of the highest order of excellence, being indefinitely more accurate than the map requires. With this, however, the accuracy appears to end. The detail consists of the map, or the map proper, little more than a compilation of commune cadastral plans. These were fitted to the triangulation points, and to one another, a process which appears to have been by no means easy of satisfactory accomplishment. This adjustment having been completed, the culture was brought up to date of survey, and a survey was made of the relief features by the use of such inferior instruments as the clinometer, compass, and chain. The principal and obvious criticism upon such work is that it is top-heavy. The triangulation is far more elaborate than is required, while the provision for making the map itself is by no means comparable with it. It is as far below the requirements of the scale as the triangulation is above it. This leads up to a broader proposition, which may be stated thus, that the general tendency of surveying organizations is in the direction illustrated by that of the French staff. Organized originally for map-making, they progress little by little in the direction of devoting their energies to geodetic work, while at the same time the topographic work proper, for which they were created, is belittled and neglected. As a consequence, the latter depreciates in quality and diminishes in quantity. The main purpose of the organization is lost, and a mere means becomes the ultimate end of the work. This tendency should be recognized in map-making organizations. The weakness of our modern maps is seldom in the primary control. It is easy to do triangulation of sufficient accuracy for the control of maps upon such scales as that above considered, little knowledge or experience being required beyond that gained at our engineering schools, while the more accurate triangulation, generally known as geodetic work, requires merely better instruments, more time, and more experienced observers. The weak features of maps are generally the details, the part of the work that, strange to say, is usually relegated to the lowest grade of professional men. This weakness consists in an insufficiency of minor locations for the control of the sketch and in unfaithful sketching. It is the sketching that requires the most careful attention and the best and most experienced men. The instrumental portion of the work is the least difficult. The artistic portion or sketching is the most difficult. It would seem more logical and would doubtless produce better results to reverse the usual order of promotion and place the topographer above the triangulator. Moreover, the triangulation should be regarded as merely a means for the correction of the sketching, and it should be required only that it be of sufficiently high grade to meet this condition. The minor location should be sufficiently numerous and well distributed to fully control and correct the sketching. And finally, the sketching should be as faithful a representative of the topography as is consistent with the necessary generalization of the surface features. H.G. End of section 26. Section 27 of National Geographic Magazine, Volume 3. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by SReisman. Notes. Polar regions. The Société de Géographie of Paris in its proceedings publishes the following communication from M. Charles Rabot on the new Danish expedition engaged in the exploration of the eastern coast of Greenland under the command of Lieutenant Ryder of the Royal Danish Navy. The expedition has in view the examination of the unknown coast between Franz Josef Fjord in latitude 73 degrees and the most northerly point reached by Commander Holm and Lieutenant Gard, about latitude 66 degrees. Lieutenant Ryder left Copenhagen June 7, 1891, in the Norwegian whaler Hekla, which had been chartered by the Danish government. The first ice was met on the 20th, in latitude 68 degrees 12 minutes, longitude 13 degrees 5 minutes west. Unable to pass through the pack to the Greenland shore after several attempts, the ship proceeded northward, and in the vicinity of Jan Mayen, made soundings and successful dredgings. Several attempts to reach the coast of Greenland were made from the 75th parallel southward, but without success up to July 2nd, when the Hekla was in latitude 71 degrees 31 minutes, longitude 6 degrees 30 minutes west. Since that date, there has been no direct news. But on July 26th, in latitude 72 degrees 40 minutes, longitude 14 degrees 25 minutes west, the English whaler Active saw the Hekla a few miles to the northeast, heading to the south-southwest. On August 2nd, the Active, in latitude 71 degrees 40 minutes, approached within 12 miles of the coast, and on August 20th, in 70 degrees 30 minutes, was within 7 miles of the mainland. In both instances, the intervening sea was free of ice. The English captain believes that the Hekla made the eastern coast in about 71 degrees 30 minutes. The Hekla is provisioned for the winter, and there is a prospect of marked success by the Danish officers in their undertaking. End of section 27.
Section 28 of National Geographic Magazine, Volume 3. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Availle in March 2014. Notes: The Crossing of Tibet. The explorations of Mr. Rockhill in Tibet and his renewed attempt to reach Lhasa, the holy city of that country, creates an unusual interest for Americans in the account of the crossing of Tibet by M.G. Bonvalot, Prince Henri d'Orléans, and P. Dedekind, published in the last bulletin of the Paris Geographical Society. 6 days' journey from Moscow brought the party through Russia and Turkestan to Kulja, 45 degrees north, 41 degrees west, in extreme western Mongolia. Having obtained authority from the Chinese governor of the province to proceed, the party, aggregating 15 in number, left that place September 12, 1889, with Batang, China, as an objective point. On October 5, after a journey of about 450 miles, during which they crossed the Tian Shan Heavenly Mountains by Narat Pass, they camped at Korla, near Bagraj Kul. Here they were warned that they could proceed no farther, and the governor of Aili sent an order to arrest them. The Mandarin and other local authorities did not, however, actively oppose their departure, which took place during the night of October 10, the party then consisting of 20 horsemen and 40 pack animals. On October 28 they reached Karaduran, the western end of Lop-Nor. A side trip by d'Orléans and Dedekind to Lop-Nor proved it to be no longer a lake, but a series of swamps and sandy islands, with the water nowhere more than 4 feet deep. Meantime, Bonavolo accumulated supplies and replaced from the hardy Mongols the more timid among their camp followers, the party being reduced to 7, with a few extra men for a short distance. Quitting Charkalik on November 17, they followed the route taken by Carey, but on the advice of the natives, they resolved after crossing the Altin Tag to go directly southward instead of turning eastward, and thus to attempt a new route, on which they were beset by the usual physical discomforts attendant on travel at great elevations. On these mountain ranges they saw only wild sheep, blue hares, wild horses, crows, and partridges. On December 5, just south of a large salt lake, Uzun Tehur, they saw a caravan of Kalmuck pilgrims returning from Lhasa by an unknown route, which they refused to make known, and decided to temporarily abandon their idea of reaching Batang and instead to go directly to Lhasa by retracing the caravan trail. From this point, about 38 degrees 30 minutes north and 87 degrees 30 minutes west, they proceeded directly southward. The region penetrated was unknown, the winds violent the entire day, the desert treeless and without water, the route lined with the carcasses of camels and their drivers, the only fuel the dung of wandering yaks or caravan camels, and the trail so indistinct that at times they marched by compass. The elevation gradually and steadily increased to 15,000 and even 16,500 feet. The mountain fever became worse, the storms more violent and continuous, and the temperature ranged from 7 degrees, (-14 degrees Celsius), with wind at midday, to 30 degrees below zero, (-33 degrees Celsius), at night. One by one their horses and camels died, and also an old Kirghiz who followed them. Extensive glaciers were passed, from which flow on the one side the Salwen and Mekong into Indian Ocean, and on the other the Yangtze to China Sea. On January 8, 1890, they skirted a large unfrozen lake named Montcalm, 50 miles long by 12 miles wide, and on January 14 traversed Duplex Pass, 20,000 feet elevation. On the 31st they finally ran across a man, a wild Tibetan, small, thin, with enormous lips, long knotted hair, clothed in sheepskin and armed with a sabre and flintlock gun, whom they called Appa, father. He knew neither Chinese nor Mogul, but spoke Tibetan, of which the travellers knew scarcely a dozen words. Other Tibetans, with flocks of sheep, soon appeared, and sold them mutton, a little salt, and rancid butter, and then followed on horseback for 15 days without losing sight of the explorers. Often they were counselled in Mogul by those in authority to turn back. In the middle of February they reached Lake Nam Tso, Heaven, or Tengri Nor, a large frozen body of water. Out of 40 camels only 15 remained, and of 20 horses but one survived. 3 of the party of 7 were in desperate state of health, while all were worn out and almost without provisions. They were finally obliged to stop in a mountain pass of the Ninjin Tangla, which led directly to Lhasa, then not more than 60 miles distant. On February 17 the Tibetan authorities sent a large party to meet them and ask their intentions. Mistaken for Russians, it took 13 days to convince the authorities that they were French. They received presents from the authorities and obtained costumes from Lhasa, but found it impossible to visit the holy city. After 49 days of negotiation, on April 5, provided with arms, provisions, and horses, and also a safe permit from the Talia Lama to cross Tibet to Batang by an unknown route, they started eastward, on a course nearly parallel to and north of Salwen River, reaching So, and once again seeing houses on April 15. They arrived at Batang early in June, their route some distance west of it having joined the imperial highway from Pekin to Lhasa, over which l'Abbé Huc travelled. From Tatsien Lu, where the French Tibetan mission is located, their route turned southward to Red River, which was reached, at Manhou, on September 21st, when their journey practically ended, as Hanoi was reached 2 days later. An excellent map of the itinerary by Prince Henri accompanies the article. A.W.G. End of section 28.
Section 29 of National Geographic Magazine, Volume 3. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Notes: Third Annual Report on the Statistics of Railways in the United States to the Interstate Commerce Commission for the year ending June 30, 1890. Washington, Government Printing Office, 1891. Advance copy, pages 1 to 100. This pamphlet by Professor Henry C. Adams is issued in advance of the full report, which is promised to comprise about 875 pages. It contains a summary, digest, and discussion of the full report. It appears that the total railroad mileage on June 30, 1890 was 163,597, an increase of 5,838 miles during the year. The increase came mainly from southeastern and western states. This mileage was owned by 1,797 distinct corporate bodies, but entirely controlled in one way or another by only 747 companies. To illustrate the extent to which consolidation of railroad property has gone, it may be stated that 47.5% of all railroad mileage is controlled by but 40 companies, and that 65.4% is controlled by 75 companies. The greatest mileage controlled by one company is 6,053, operated by the Southern Pacific Company. The total capital and bonded debt of railroad companies was $9,871,378,389, or $60,340 per mile. Stock and bonds were about equal in amount. Mr. Adams estimates the value of railroad property by capitalizing at 5% the dividends and interest on bonds paid during the year, reaching as a result $6,627,461,140, or about two-thirds of the nominal capital and bonded debt. The justice of this method may fairly be questioned. A comparison of the ruling prices of dividend-paying stocks with the rate percent of the dividend shows that 5% stocks are above par and that 4% stocks average nearly par. Moreover, it is well known that many railroads are built and operated not for their own immediate earnings, but to give value to other property of the companies, notably to lands, from the sale or lease of which the companies derive profits. Again, many railroads are built not for present but for future profits, after they shall have induced settlement of their territory. And, furthermore, numerous branch roads have been built as defensive measures to prevent rivals from occupying territory. And in many cases, earnings are used in betterment of property instead of distributing it as dividends. In all these cases, the roads have value, although they are not paying dividends. Taking all these matters into account, it does not appear that the railroad stocks of the country have collectively been watered to any great extent, if by watering is meant expanding nominal values above actual values. Concerning dividends paid on stock, Mr. Adams presents a table showing that 63.76% of all stock paid no dividends, that but 6.47% paid less than 4%, that 25.26% paid from 4 to 8%, the remainder paying above 8%. It appears that in the northeastern states much the highest dividends were paid, while in the West, so far as dividends are concerned, the stockholders have to wait for future developments. The total passenger mileage for the year was 11,847,785,617, a slight increase over the previous year. The total freight mileage was 76,207,047,298, an increase of nearly 10% over that of the previous year. The gross earnings of the year were $1,051,877,632, and the operating expenses $692,093,971, leaving as the income from operations $359,783,661. The income from other sources was $126,767,064, and the total deductions from income were $384,792,138, leaving as the net income $101,758,587, out of which there was paid as dividends on stock $89,688,204. The magnitude of the railway interests of the country is set forth in the above enormous figures. It is still further emphasized by the fact that nearly 750,000 men are in the employ of this industry. Assuming that each such employee supports 2 others besides himself, it is seen that the railroad interest supports 2.25 millions, or more than 1/30th of the inhabitants of the country. H.G. End of section 29. End of National Geographic Magazine, Volume 3.